computing. So I would like to introduce Dr. M.V. Takre, sir. He has completed his PhD in theoretical physics. He has completed MOOC from University of Minnesota, USA, and University of Swinburne, Australia, with distinction. Now, currently, he is assistant professor in the Department of Physics. He has the skills, that is software literacy, mathematics, Linux, etc. So he is doing highly renowned research in well-known research in the field of physics. His citations are 827. H index is 18. I-10 index is 24. And ResearchGate score is 26.11. He has worked in various capacities at the university level. He is NAC coordinator of Department of Physics, Shivaji University, Kolhapur. He has worked as a visiting faculty in Karnataka University, Dharwad, PG Center, Mumbai, Mumbai University at JJ College, Ratnagiri. He is a member of BOS of Shivaji University, Kolhapur, YC College, Satara, KIT College of Engineering, Kolhapur. He has following memberships with him. He is a member of Optical Society of America. He is member of Indian Physics Association, Indian Laser Association, Laser and Spectroscopy Society of India, Photonics Society of India, Indian Association of Physics Teachers, life member of Indian Science Congress, Art Society of India, Bombay, Art Society affiliated to Lalit Kala Academy, New Delhi, Jahangir Art Gallery, etc. So he has, to his credit, he has memorable distinctions. I also would like to welcome you, sir, and I request you to present your valuable thoughts regarding experimental physics. I would also briefly introduce Honorable Principal Dr. R.S. More, sir, who is working as a principal in Balwant College, Vita, for last 1.5 years. He has experience of working as a principal in various colleges of Rayat Shikshan Samstha for last 11 years. And recently, he has bagged the Excellent Teacher Award of Lokmat, and he is now selected as life member of Rayat Shikshan Samstha. So he is a very active person who is always motivating our departments to carry out the activities which are beneficial for students. Also, I would like to introduce President of today's function, Professor A.B. Tapase, sir. Currently, he is working as Associate Professor in Chemistry. He is PG Coordinator of Department of Chemistry, and he has teaching experience of over 32 years. So, again, I welcome you all, and I request that all the students, whether you are PG or UG student, should take benefit of the well-prepared talk of M.V. Takre, sir, which will be beneficial to you. Thank you once again. Over to Priyanka, madam.
Thank you, sir, for such a brief introduction of the chief guest and president of this function, as well as the principal of our college. May I now request the chief guest of this function, Honorable Dr. M.V. Takre, sir, to enlighten us with precious words.
Hello, good morning. Am I audible?
Yes, sir.
Yes, sir.
Me mixed mode नहीं बोलता हूँ basically. So wherever I need English, wherever I need Marathi, whatever it may be, but I'll prefer to have a mixed mode so that audience will not also get a little bit bored. Okay. First of all, I'm very much thankful for organizing committee, especially principal of the college, head of the Department of Physics, and his colleagues who invited me in such a busy schedule. Space for me, such as computation and its relation with experimental physics. But right now I could I decided to talk on this direction by telling you a small story wherever the role of computation in experimental setup is there, and which is quite crucial. मला एक बेसिकली जास्त काय मी मॅथमॅटिकाचं डिटेल्स फार बोलणार नाही बिकॉज ऑफ द टाइम अलॉटेड टू मी, बट आय वुड लाईक टू टेल यू वन स्मॉल स्टोरी की ज्यावेळी आपण पोखरणला न्यूक्लिअर एक्सप्लोजन केलं तर ते न्यूक्लिअर एक्सप्लोजन डायरेक्ट काय जाऊन नाही केलं, तर पहिल्यांदा इट वॉज फर्स्ट ऑफ ऑल इट वॉज सिम्युलेटेड ऑन अ सुपर कम्प्युटर, आणि मग सुपर कम्प्युटरवर सिम्युलेशन्स करून एक्सप्लोजनची स्ट्रेंथ किती आहे किंवा तो शॉक क्रस्ट मधून किती डिस्टन्स पर्यंत प्रोपोगेट होईल हे कम्प्युटेशननी अगोदर एस्टिमेट केलेलं, आणि देन पीपल डिसाइडेड की किती स्ट्रेंथचा न्यूक्लिअर एक्सप्लोजन करायचं. So the whole thing before entering into the actual lab, nowadays people have a great practice of doing certain kind of simulations related to that experiment. ही आजची स्थिती आहे. म्हणजे आणि आता तर पॅराडामिक सिच्युएशन मुळे काही चांगल्या नॅशनल लॅबनी तर आपल्या सगळ्या रुटीन लॅब्स आहेत त्या व्हर्च्युअल लॅब मध्ये कन्वर्ट केलेल्या आहेत. त्यामुळे डायरेक्टली गोइंग टू द ऍक्च्युअली लॅब, बिफोर गोइंग टू द लॅब पीपल प्रेफर टू हॅव इट्स अ सिम्युलेशन. पहिल्यांदा गोष्टी सिम्युलेशन करून बघायच्या. दिस इज अ ट्रेंड नॉट ओनली इन रिसर्च बट इन डे टू डे प्रॅक्टिस ओनली. बऱ्याच चांगल्या इन्स्टिट्यूशन्स मध्ये असं दिसतंय की लॅबमध्ये जाण्यापूर्वी त्यांना व्हर्च्युअल एक्सपिरियन्स दिला जातोय त्या एक्सपेरिमेंटल सेटअपचा, अँड देन पीपल एंटर इन टू ऍक्च्युअल लॅब, फिजिकल लॅब, अँड व्हेरेवर दे परफॉर्म दिस काइंड ऑफ ए ऍक्च्युअल एक्सपेरिमेंट. तर त्यामुळं हा जो काय प्रकार आहे कम्प्युटेशन, सिम्युलेशन, ॲनिमेशन, तर याला डिजिटल एज्युकेशन मध्ये किंवा सध्याच्या एज मध्ये डिजिटल एज मध्ये खूप इम्पॉर्टन्स आलेला आहे. तर त्यातला जो एक थोडासा भाग आहे एकदम छोटा विच विल अट्रॅक्ट द स्टुडंट्स टू दिस काइंड ऑफ अ थिंग, आणि या प्रकारची सॉफ्टवेअर लिटरसी ही मच अर्लियर एजला मुलांना दिली तर एकतर सॉफ्टवेअर लिटरसी पण होतीये स्टुडंटची, आणि ही गेट वेल वर्स्ड विथ सच थिंग्स की जे त्यांना पुढे गेल्यानंतर रिसर्चला उपयोगी पडते. जर माझ्या फील्ड मधला जर रिसर्च बघायला गेला तर पेन आणि कागद घेऊन करण्यासारखा तो राहिलेला नाही आहे, बिकॉज द डेप्थ ऑफ द कॅल्क्युलेशन अँड लेंथ ऑफ द कॅल्क्युलेशन इज टू सच अन एक्सटेंट की ते हाताने करणं तर वर्षात एखादाच पेपर कदाचित होऊ शकेल. बट इफ यू टेक अ हेल्प ऑफ सच अ सॉफ्टवेअर्स then computing becomes a very fast, and nowadays these are actually classical computers that whatever we are using right now, but if you go to the quantum computers the speed of computation has increased to many folds, more than much more crore times many fold than the whatever the classical computers are doing right now. तर या सगळ्या गोष्टी विचारात घेतल्या तर रिसर्च ऍक्सलरेट होतोय आणि काही गोष्टी पटकन तुम्हाला करून बघता येतात बिफोर गोइंग टू ऍक्च्युअल प्रॅक्टिकल सिच्युएशन. हा ऍक्च्युअली या सॉफ्टवेअरचा रोल आहे. किंबहुना इनफॅक्ट मॅथमॅटिका वापरून तुम्हाला व्हर्च्युअल लॅब्स पण क्रिएट करता येतात. खरं त्याच्याकरता काही वेगळी पॅकेजेस वगैरे आहेत. तर वी हॅव दिस फॅसिलिटी रिसेंटली परचेस फ्रॉम वुल्फ्रॉम रिसर्च, की आपला आत्ता जो मॅथमॅटिका आहे तो युनिव्हर्सिटी प्रोव्हाइड केलेला कम्प्युटेशनल फॅसिलिटी आहे. So I'm also thankful for that. And the very important thing about this software is that this software was firstly introduced by Dr. Sharad Navre in the university. And this computational facility was brought in the physics department first time with the kind efforts of Dr. Sharad Navre. So I'm also thankful to all those people who could make this facility available for all of us, including research community as well as for the academic community outside the colleges, outside the department. So I'll deal some of the things which are quite simple, elementary, but very interesting, and so that you can enjoy those things. हे जे सॉफ्टवेअर आहे मॅथमॅटिका ते वुल्फ्रॉम रिसर्च या कंपनीचं आहे, आणि त्याच्यामध्ये त्याचा जो पायोनियर आहे, फादर आहे, तो बेसिकली थिअरेटिकल फिजिसिस्ट आहे, की विच वॉज व्हेरी स्मार्ट थिअरेटिकल फिजिसिस्ट, इज theoretical physicist, and he has written a very good books, आणि त्याचा एक थोडासा ओव्हरव्ह्यू देणं मला इम्पॉर्टंट वाटतंय. So I'll give you its overview over here. See this Mathematica. He is Stephen Wolfram who actually gave or developed this software. And see, there are two books in the front of his desk that new kind of a science. So he has written that book, which is gives you an idea about by using or employing a Mathematica, how research can be accelerated or can lead to new things. So he's a creator of Mathematica. आणि आता हा जो मॅथमॅटिकाचा व्हर्जन चालू आहे तो येऊ घातलेला व्हर्जन आहे 13, बट वी आर युझिंग दिस 12.3 लायसन्स कॉपी ऑफ डिपार्टमेंट ऑफ फिजिक्स. आणि त्याच्यामध्ये आता ही सगळी जी प्रेझेंटेशन सुद्धा आता जे मी केलेलं आहे ते प्रेझेंटेशन सुद्धा मी केलेलं प्रेझेंटेशन आता जे आहे ते सगळं तुम्हाला दिसेल की मॅथमॅटिका हे सॉफ्टवेअर वापरून केलेलं आहे. So there are certain useful publications that those people who are interested to know what Mathematica is. So Mathematica, its introduction, Mathematica for physicists, the project to find the fundamental theory of physics. Wolfram language has been also developed by Wolfram Research. ही एक language आहे जसे आपले programming languages असते, which is different than this what is we call as a Mathematica software. So Wolfram language is also a certain kind of language, programming language developed by the Stephen Wolfram, and there are various publications. So almost all books, standard books, now they have got a support through Mathematica. So Mathematica can give them support or a companion sort of thing to solve problems. So एक जर तुम्ही ब्लॉग बघितला स्टीफन वुल्फ्रामचा तर भवितव्यात त्यांनी असं सांगितलंय की तुम्ही मॅथमॅटिक्स शिका, बट मॅथमॅटिक्स प्रॉब्लेम सॉल्व्ह करून शिकू नका, तर मॅथमॅटिका यूज करून शिका. म्हणजे मॅथमॅटिक्स अंडरस्टँड करा, परंतु सॉल्व्ह करायचं काम जे असेल ती मॅथमॅटिका करेल. यू डोंट नीड अ पेन अँड पेन्सिल टू सॉल्व्ह ऍक्च्युअली प्रॉब्लेम्स. सॉल्विंग जो अस्पेक्ट आहे, कम्प्युटेशन जो अस्पेक्ट आहे तो इट विल बी लुक्ड अपॉन बाय मॅथमॅटिका. सो या लेवलला भवितव्यात तुमचं मॅथमॅटिक्सचं एज्युकेशन सुद्धा जाऊ शकतंय. सो ही एक अतिशय हाय लेवल सॉफ्टवेअर आहे. जस्ट लाईक मॅटलॅब, मोस्ट ऑफ द टाइम्स पीपल यूज मॅटलॅब. इंजिनिअरिंग सेक्टरमध्ये मॅटलॅब हे खूप पॉप्युलर आहे. तर त्याच पोटेन्शियलचं, त्याच दर्जाचं मॅथमॅटिका इज ऑल्सो अ सॉफ्टवेअर ओव्हर हिअर. आणि त्याचे खूप ब्लॉग्स वगैरे आहेत. तर ते ब्लॉग जर तुम्ही वाचले, इथं साइट्स आहेत बघा मी दिलेल्या, सी ऑल दिस साइट्स आर हिअर. So if you go to that slide www.wolfram.com, तर त्याला त्याच्या खाली तुम्हाला खूप सगळे ट्रायल बुक्स, पब्लिकेशन्स, डेमो प्रोजेक्ट्स, एव्हरीथिंग यू विल गेट ऑल दोज थिंग्स. सो दिस इज बेसिक एक्सपान्शन ऑफ अ मॅथमॅटिका. और जे काय त्याचा विस्तार आहे, मॅथमॅटिकाचं पोटेन्शियल आहे किंवा त्याची युटिलिटी आहे, ते सगळे तुम्हाला या ठिकाणी मी दाखवलेली आहे थोडक्यात. बट आय डिडंट गो इन मच डिटेल्स. सो गेटिंग अक्वेंटेड विथ मॅथमॅटिका, तर सर्टन रूल्स आहेत. फक्त थोडे रूल्स सांगतो मी, अँड देन आय विल डायरेक्टली गो टू द युजर एंड ऑफ मॅथमॅटिका किंवा कशी एक्झिक्यूट होते ती. तर मॅथमॅटिका ही केस सेन्सिटिव्ह आहे. म्हणजे त्याच्यात कॅपिटल लेटर आणि स्मॉल लेटर याचं डिस्टिंक्शन मॅथमॅटिकाला होत आहे. ऑल बिल्ट इन फंक्शन्स अँड कमांड्स ऑलवेज इनिशिएट विथ द कॅपिटल लेटर्स. म्हणजे त्यात जी बिल्ट इन फंक्शन्स आहेत, साइन हे ट्रिग्नोमेट्रिक फंक्शन असेल किंवा लॉग असेल, तर ऑल दिस बिल्ट इन फंक्शन्सचं पहिलं जे लेटर असते ते कॅपिटल असते. आणि स्क्वेअर ब्रॅकेट्स आर यूज टू फॉर फंक्शन आर्ग्युमेंट्स, राउंड ब्रॅकेट्स आर यूज फॉर ग्रुपिंग, कर्ली ब्रॅकेट्स आर यूज फॉर असाइनमेंट, लिस्ट. आणि असाइनमेंट करता लेफ्ट साइड टू राईट साइड असाइन करण्याकरता इक्वल टू साइन वापरतो. डबल इक्वल टू मॅथमॅटिकामध्ये टाईप केलं तर त्याचा अर्थ नेहमीच आपलं मॅथमॅटिकामधलं इक्वल टू होतोय. आणि डिलेड असाइनमेंट करता कोलन इक्वल टू वगैरे टाकतो. सो जनरली हे रूल आहेत. हे आता मी जर हँड्स ऑन एक्सपिरियन्स द्यायचा झाला तर त्यावेळी हे सगळ्या गोष्टी मी जनरली सांगतो. सो आता काय त्याची फार डिटेल्सची आवश्यकता नाही आहे. सो आय विल क्लोज दिस सेल. हे सेल मला क्लोज करता येतात. आणि हे जे काय प्रेझेंटेशन दिसतंय, हे प्रेझेंटेशन सुद्धा मी मॅथमॅटिका मधूनच केलंय. सो मॅथमॅटिका कॅन ऑल्सो बी युज्ड एज अ प्रेझेंटेशन टूल. मॅथमॅटिकाचं पोटेन्शियल खूप आहे. इट कॅन बी युज्ड एज अन ऑथरिंग टूल, कम्प्युटेशन, प्रेझेंटेशन, आर्टिकल, बुक क्रिएट करण्याकरता. सो ऑल सॉर्ट्स ऑफ थिंग यू कॅन यूज थ्रू मॅथमॅटिका. मी प्रेझेंटेशन केलंय हे सुद्धा मॅथमॅटिका मधून केलंय. सो एक सिंपल काही इक्वेशन्स कशी सॉल्व्ह करायची त्याचे काही सिंपल एक्झाम्पल्स आय विल कोट इट हिअर किंवा सोडवून दाखवतो. सपोज दिस वी हॅव अ इक्वेशन 7x + 3 इक्वल टू 3x + 8 आणि हे मला इक्वेशन सॉल्व्ह करायचं आणि याच्यात एक जो अननोन आहे त्याची व्हॅल्यू काढायची आहे. तर आय यूज जनरली दिस कमांड सॉल्व्ह. सॉल्व नावाची कमांड वापरतो. कमांड वापरली की स्क्वेअर ब्रॅकेट असतो आणि या लेफ्ट साइडला राईट साइड इक्वेट केली इक्वल टू, त्यामुळे डबल इक्वल टू साइन मी टाकलंय आणि ही सॉल्व ही कमांड दिली आहे आणि कमांडचं पहिलं लेटर कॅपिटल आहे रूल प्रमाणे. तर मी हे नुसता सेल एंटर केली तर तुम्हाला लक्षात येईल की त्या ठिकाणी तुम्हाला x ची व्हॅल्यू 5/4 मिळते. सो दिस कमांड सॉल्व जे काय आवश्यक आहे ती सगळी प्रोसिजर मॅथमॅटिकल प्रोसिजर ते आत करत आहे. म्हणजे व्हेरिएबल्स एका बाजूला शिफ्ट करायचे, कॉन्स्टंट दुसऱ्या बाजूला आणि मग इव्हॅल्युएट करायचं, हे सगळं काम असेल ते मॅथमॅटिका आतून करताय या सॉल्व या कमांड खाली. सो त्याच्या बॅकएंडला म्हणजे याला आपण जे समोर दिसतंय त्याला आपण म्हणतो फ्रंट एंड आणि बॅकएंडला त्याचा एक याला कनेक्ट करणारा एक केर्नेल असतोय आणि तो बॅकएंडला सगळं कॅल्क्युलेट करून फ्रंट एंडला तुम्हाला परत रिझल्ट काय करतो डिस्प्ले करतो. सो आपण इथं एकच व्हेरिएबल होता त्यामुळे मी नाही सांगितलं. सपोज इफ आय हॅव बायव्हेरिएट म्हणजे दोन व्हेरिएबल असणारे इक्वेशन्स आहेत 3x 7x + 3 आणि 3y + 8 आणि त्यातल्या माझ्या एकाच व्हेरिएबल करता मला काय पाहिजे आहे आन्सर पाहिजे आहे. बट आय विल गेट आन्सर इन टर्म्स ऑफ अदर व्हेरिएबल. त्यामुळे मी हे एंटर केलं तर तुम्हाला इथं लक्षात येत असेल की x = 1/7 5 + 3y म्हणजे मला याचं सोल्युशन x करता मिळत आहे आणि इन टर्म्स ऑफ y मिळत आहे. So instead of single variable, if you have two variables, you can also solve it. आता तेच इक्वेशन मी लिहिलंय, but now I am going to ask for y. What will be solution for y in terms of x? तर it gives you its answer or solution in terms of x. So असं तुम्ही solve ही सिंगल कमांड घेतली तर तुम्हाला त्यात करता येते. आता एक गोष्ट याच्यामध्ये वरची तिन्ही एक्झाम्पल्स घेतले त्यात नंबर्स आहेत. नंबर्स आर देअर. जर तुम्ही एखाद्या प्रोग्रामिंग लँग्वेज मध्ये एखादा सिम्बॉल टाईप केला A, B, X, Y तर ते प्रोग्रामिंग लँग्वेज तुम्हाला सांगते की तो डिफाईन करा अगोदर. सो इट इज नॉट डिफाईन्ड किंवा अनडिफाईन्ड असं डिक्लेरेशन असतं. बट मॅथमॅटिका इट्स स्पेशालिटी इज दॅट इट डझंट आस्क फॉर व्हॉट इज A, व्हॉट इज B, व्हॉट इज X. इट डझंट आस्क. तर इथं मी एक इक्वेशन घेतलंय फॉर एक्झाम्पल सिम्बॉलिक इक्वेशन घेतलंय x = B आणि मी म्हटलं गेट सोल्युशन फॉर x. तर मॅथमॅटिका नेव्हर आस्क की A काय आहे तुमचा किंवा A डिफाईन केला नाही किंवा B काय आहे किंवा B डिफाईन केला नाही असं काही नाही विचारत. सो व्हॉट इज द ब्युटी ऑफ दिस सॉफ्टवेअर? इट डज बोथ द काइंड्स ऑफ कम्प्युटेशन. इट डज न्यूमेरिकल कम्प्युटेशन as well as it does a symbolic computation. म्हणजे इट नेव्हर आस्क व्हॉट इज A, व्हॉट इज B. इट जस्ट टेक ॲज इट इज अँड गिव्स यू आन्सर x = B/A. सो इट नेव्हर आस्क. अदरवाइज तुम्ही प्रोग्रामिंग लँग्वेज मध्ये गेला तर ते तुम्हाला डिफाईन करायला लावतात, ऍड्रेसेस तुम्हाला लोकेट करायला सांगतात. सो सच काइंड ऑफ थिंग्स आर नॉट हिअर. इट जस्ट गिव्स यू आन्सर, टेक्स अवे x to one side and gives its answer x = something. So x = B/A. It never asks what is A, what is B. If you are asking to solve it for x, then it gives you answer for x, but in terms of B and A, it never asks what is B and what is A. So this is what we call as a symbolic computation. वरचं जे केलंय आपण पहिल्या 3 एक्झाम मध्ये that is a numerical computation. Wherever you get answer in terms of number. So symbolic computation, numerical computation या सगळ्या गोष्टी तुम्ही याच्यामध्ये अगदी बिंदास करू शकता. काही इश्यू येत नाहीये. आता सपोज मी काही थोडी अशी एक्झाम्पल्स घेतो. सपोज हिअर आय हॅव गॉट अ पॉलिनॉमियल. इथे एक मी रूट्स नावाचा एक ऍड्रेस तयार केला. म्हणजे याच्यामध्ये मॅथमॅटिकामध्ये सॉल्व ही कमांड वापरली आहे आणि ही जी पॉलिनॉमियल आहे 6 डिग्रीची, ही 6 डिग्रीच्या पॉलिनॉमियलची मी रूट्स काढायला सांगतो. सो आय एम आस्किंग टू फाइंड आउट रूट्स ऑफ दिस 6 डिग्री पॉलिनॉमियल बाय युझिंग अ कमांड सॉल्व. आणि जी काय रूट्स निघतील ती किंवा याची जी काय सोल्युशन्स निघतील 6 डिग्रीची 6 सोल्युशन्स निघतील, ती रूट्स या नावाच्या ऍड्रेस एक क्रिएट केला आणि त्याच्यामध्ये मी स्टोअर केले. सो इफ आय शॅल एक्झिक्यूट दिस कमांड आय विल गेट अ लिस्ट ऑफ लिस्ट. या ठिकाणी तुम्हाला काय बघा लिस्ट ऑफ लिस्ट मिळाली. x = 1, x = 2, 3, 4, 5, 6 ह्या एक्सच्या व्हॅल्यूज आहेत. म्हणजे या एक्सच्या व्हॅल्यूज जर घातला तर या 6 व्हॅल्यूज आहेत. ही प्रत्येक व्हॅल्यू या एक्सच्या ठिकाणी घेतली तर राईट हँड साइड तुमची काय होऊ शकते 0 होऊ शकते. आणि हे जे काय सोल्युशन आहे याचं 6 डिग्री पॉलिनॉमियलची रूट्स काढलेली आहे ते मी स्टोअर केलंय. कुठल्या ऍड्रेस मध्ये? तर रूट्स नावाच्या ऍड्रेस मध्ये मी काय केलंय स्टोअर केलंय. आता बघा त्याच्या पुढची मी कमांड काय केलेली आहे. रूट ऑफ एक्स रेस टू 5 स्लॅश डॉट रूट्स असं मी एक कमांड केलेली आहे. याचा अर्थ काय, तर मला फिफ्थ रूट काढायचा आहे, स्क्वेअर रूट घ्यायचा आहे त्याचा, म्हणजे जे रूट आहे ते रूटचं फिफ्थ पॉवर घेऊन ते स्क्वेअर रूट खाली घालायचं आहे. परंतु हा एक्स त्यानं कुठून घ्यायचा, तर एक्स हा त्यानं डॉट रूट्स नावाच्या ऍड्रेस मधून घ्यायचा किंवा रूट्स नावाच्या ऍड्रेस मधून घ्यायचा. तर मॅथमॅटिका मध्ये याला आपण एंड कमांड म्हणतो. स्लॅश देऊन डॉट टाकून रूट्स लिहिला तर रूट्स नावाच्या या ऍड्रेस मध्ये जेवढे काही न्यूमरिक्स स्टोअर केलेले असतील ते इथं घेतले जातील आणि त्याचं एक्स रेस टू 5 करून त्याचं स्क्वेअर रूट घेऊन तुम्हाला काय दिलं जाईल, त्याचा आन्सर जाईल. सो हिअर सी यू कॅन फाइंड इट हिअर. 1 1 4 रूट 2 9 रूट 3 32 25 रूट 5 36 रूट 6 हे सगळे त्याचे फिफ्थ पॉवर घेऊन स्क्वेअर रूट घेतल्यानंतर जे काय मिळतंय ते आन्सर इथं हे करता येतं. सो देर आर सो मेनी थिंग्स. म्हणजे या सगळ्या अल्जिब्राइक गोष्टी मी काय फारशा दाखवत बसत नाही आहे. So there are certain things by which you can find out roots. There are different methods to find out roots. म्हणजे ग्राफिकली सुद्धा तुम्ही काढू शकता एखाद्या गोष्टीचं रूट. तर इथे बघा मी एक नवीन एक इक्वेशन घेतलंय की ज्याला मी कमांड दिली फाइंड रूट. खरं हे जे इक्वेशन आहे हे तुमचं ट्रान्सिडेंटल फंक्शन्स मध्ये आहे. ट्रान्सिडेंटल फंक्शन्स याचा अर्थ आपल्याकडे ट्रिग्नोमेट्रिक, अल्जेब्राइक किंवा लॉगॅरिथमिक, एक्सपोनेन्शियल, अल्जेब्राइक सोडून द्या, ट्रिग्नोमेट्रिक, लॉगॅरिथमिक, एक्सपोनेन्शियल, हायपरबोलिक ही सगळी जी फंक्शन्स आहेत त्यांना आपण काय म्हणतो, बेसिकली वी कॉल देम ॲज अ ट्रान्सिडेंटल फंक्शन्स. सो हे जे इक्वेशन आहे दॅट इज बेसिकली ट्रान्सिडेंटल इक्वेशन. 2 exponential raised to 2x plus 1 equal to means mathematically equal to 3 sin x x 3 असं मी काहीतरी दिलंय आणि मी म्हटलं याचं मला रूट काढायचं आहे. आय वॉन्ट टू सॉल्व दिस इक्वेशन अँड गेट इट्स रूट. तर मी आता एक्झिक्यूट केलं तर त्याचं रूट इथं निघतंय -3.4821. आता इथं खाली मी एक फंक्शन लिहिलंय बघा, एफ ऑफ एक्स एक्स अंडरस्कोर लिहिलंय मी. ज्यावेळी मॅथमॅटिकामध्ये तुम्ही फंक्शन रिप्रेझेंट करता त्यावेळी अशी डिलेड असाइनमेंट करता, कोलन इक्वल टू. आणि एक्स अंडरस्कोर लिहायचं कारण असं, कारण एक्स मग तुमचा अल्फा न्यूमरिक काही एक्सेप्ट करू शकतो. अल्फा न्यूमरिक याचा अर्थ एक्सला जर तुम्ही एखादा सिम्बॉल ट्रान्सफर केला तरी पण तो घेऊ शकतोय, नंबर ट्रान्सफर केला तरी पण तो एक्सची व्हॅल्यू घेऊ शकतोय. सो दॅट इज कॉल्ड एज अ अल्फा न्यूमरिक. आणि मी इथे एक लिहिलंय 5 cos x -4 + x क्यूब असं एक लिहिलंय. आणि मग मी याचं हे फंक्शन लिहून मी हे प्लॉट केलंय -1 to 2 आणि मग त्याचं रूट काढलंय वेगवेगळ्या इनिशियल व्हॅल्यूला. सपोज दिस इज हा प्लॉट काढलाय मी 5 cos x -4 + x raised to 3. हे एक फंक्शन आहे माझं. हे फंक्शन मी प्लॉट केलंय किती, कुठल्या रेंज मध्ये, तर -1 to 2. बघा या डाव्या बाजूला तुम्हाला बघितलं इथं तर तुम्हाला असं दिसतंय -1 आहे आणि या इथपर्यंत गेला, ही ऑरेंज लाईन आलेली आहे, तर इथपर्यंत बघितला तर तुम्हाला 2 पर्यंत गेलेलं दिसतंय. सो यू कॅन प्लॉट दिस फंक्शन इन द इंटरवल -1 to 2. आता हे इक्वेशन मला जर सोडवायचं असेल, इफ आय वॉन्ट टू फाइंड आउट दिस रूट ऑफ दिस इक्वेशन, किंवा हे याची एक्सची व्हॅल्यू काढायची असेल की जेणेकरून या इक्वेशनची व्हॅल्यू 0 मिळते, तर मला या ग्राफवरून असं दिसतंय की या वाय ऍक्सिस वर तो 0 होण्याकरता या एक पॉइंटला 0 होतोय या, आणि या इथे या एक पॉइंटला 0 होतोय. म्हणजे -0.5 च्या इथे एकदा तो 0 व्हॅल्यू देतोय आणि या इथं 1 च्या आसपास 0.6 0.7 च्या आसपास एकदा तो 0 व्हॅल्यू देतोय. सो फाइंड रूट नावाची जर मी कमांड वापरली तर त्याला मला इनिशियल गेस द्यायला लागतोय. म्हणजे इनिशियल गेस म्हणजे काय, की त्याचं रूट कुठं असण्याची, कुठल्या व्हॅल्यूच्या जवळ असण्याची शक्यता आहे. तर मी पहिल्यांदा ते फंक्शन प्लॉटच करून बघतोय आणि मग त्याची व्हॅल्यू सपोज इथं -0.5 च्या जवळ आहे, तर माझा इनिशियल गेस मी -0.5 लिहितो आणि फाइंड रूट नावाची कमांड वापरली की आय कॅन गेट इट्स रूट. किती आहे ते रूटची व्हॅल्यू मला इथं मिळते. सो सच अ थिंग्स, देर आर मेनी सच अ फॅसिलिटीज, प्लॉटिंग फॅसिलिटीज, न्यूमरिकल फॅसिलिटीज, न्यूमरिकल कम्प्युटेशन आणि खूप उत्तम दर्जाचं अल्जिब्राइक मॅनिप्युलेशन्स मॅथमॅटिका करू शकतात. बट अपार्ट फ्रॉम दॅट, मॅथमॅटिका इज नॉट मिअर अल्जिब्राइक कम्प्युटेशन करणारी गोष्ट नाही आहे. तर मॅथमॅटिका कॅन ऑल्सो डू सिम्युलेशन्स, मॅथमॅटिका कॅन ऑल्सो डू ॲनिमेशन्स, किंवा 2 डायमेन्शनल किंवा 3 डायमेन्शनल प्लॉट सुद्धा ते काढू शकतात. सो आय वॉन्ट टू गो इन सच थिंग्स. मी तुम्हाला ते जास्त इंटरेस्टिंग आहे, मी तुम्हाला त्या गोष्टी दाखवतो. सो हिअर आय हॅव क्रिएटेड अ सेल कॉल 2 and 3 dimensional graphics and simulations. तर ही मी सेल ओपन करतो आणि आता तुम्हाला यू विल फाइंड दॅट वंडरफुल थिंग्स इथं तुम्हाला खूप बघायला मिळतील. हे कोलन टाकलेलं आहे शेवटी, सेमी कोलन कुठल्याही कमांडच्या इथं. सो मेनी कमांड्स आर देअर आणि हे सगळ्या एकाच सेल खाली ठेवलेत मी. तर तुम्ही ते हवं तर वेगवेगळ्या सेल्स मध्ये ठेवू शकता. यू कॅन कीप देम अपार्ट हिअर. सॉरी. सो हिअर यू कॅन कॅन्सल दॅट सेमिकोलन. सेमिकोलन कॅन्सल केला तर मग त्याचा आउटपुट दिसतंय. समजा मी सेमिकोलन टाकला तर आउटपुट दिसत नाही, त्याला म्हणायचं आउटपुट सप्रेस करायचं. एखादा फुल लेंथ प्रोग्रामिंग तुम्ही प्रोग्राम लिहिला किंवा कोड्स लिहिले मॅथमॅटिकामध्ये आणि मधल्या स्टेप्स तुम्हाला कम्प्युट करून नको आहे, अननेसेसरीली ते काय करताय की डिस्प्ले करताय, आउटपुट देत आहे आणि मला काय त्याची गरज नाही त्या मधल्या स्टेप्सची. तर यू कॅन एंड दॅट कमांड बाय टर्मिनेटिंग बाय पुटिंग अ सेमिकोलन देअर. सेमिकोलन तिथं टाकायचा तर आउटपुट सप्रेस होत आहे. आता मी सेमिकोलन काढून टाकतो आणि हे फंक्शन प्लॉट करतो, कुठलं एक्स स्क्वेअर. तर या काही सिंपल अल्जेब्राइक फंक्शन्स असतात, त्याचा आपल्याला कितपत सेन्स आहे हे गेस करण्याकरता अगोदर आपण गेस करायचं. म्हणजे याचा प्लॉट असा दिसेल, याचा प्लॉट असा दिसेल आणि प्रत्यक्षात मॅथमॅटिकामध्ये एक सिंगल लाईनचं तुम्ही हे लिहून कमांड लिहून त्याचा तुम्ही काय करू शकता, प्लॉट काढू शकता. सो एक्स स्क्वेअर हे माझ्या अल्जेब्राइक अंडरस्टँडिंग प्रमाणे इव्हन फंक्शन आहे. इव्हन फंक्शन हे वाय ऍक्सिसच्या भोवती सिमेट्रिक असतं आणि त्या एक्सला मी रेंज दिलेली आहे -2π to 2π + 2π. आता पाय म्हणजे 3.14 म्हणजे -6.28. हे बघा इथं एक्स ऍक्सिसवर -6.28 पासून +6.28 पर्यंत तो प्लॉट व्हेरी झालाय. त्याचे एंड लिमिट्स तुम्हाला इथं प्लॉटचे कळते. शिवाय एक्स स्क्वेअर हा पॅराबोला असतो अबाउट वाय ऍक्सिस आणि ते इव्हन फंक्शन आहे, सो इट हॅज टू बी सिमेट्रिक अबाउट वाय ऍक्सिस. हे तुम्हाला इथं क्लिअर दिसतंय. मला हे जर काही करायचं नसेल फॉर एक्झाम्पल आणि अगोदर गेस करून विचारायचं असेल तर आय विल जस्ट आस्क की मला हे सांगा की हा प्लॉट कसा दिसेल. तर मी याचा आउटपुट हवं तर काय करतो, डिलीट करतो अँड आय विल जस्ट आस्क स्टुडंट की याचा प्लॉट कसा दिसेल. याचा प्लॉट कसा दिसेल अगोदर गेस करायला लावायचा आणि मग असं प्लॉट काढून दाखवायचं. सो सिमिलरली यू कॅन हॅव मल्टिपल प्लॉट्स. एकाच विंडोमध्ये तुम्हाला असंख्य प्लॉट काढता येतात. फॉर एक्झाम्पल हा प्लॉट मी घेतो. माझ्या इथं दोन फंक्शन्स आहेत, एक आहे एक्स स्क्वेअर आणि दुसरा आहे 10 sin x. हे दोन मी फंक्शन्स घेतले आणि दोघांना मी रेंज दिलेली आहे -2π to +π आणि मी सेमिकोलन काढून टाकला आणि दोन्ही जे प्लॉट्स आहेत ते एकाच विंडोमध्ये यायचे. तर यू विल गेट हिअर बोथ द प्लॉट्स इन अ सिंगल विंडो. आता त्याच्यामध्ये तुम्ही कलर सेपरेशन आपोआप होत आहे. जरी नाही दिलं तुम्ही त्याला कर्वला कलर सेपरेशन नाही सांगितलं तरी ते कलर सेपरेशन आपोआप करून घेता. हवं तर तुम्ही कलर्स पाहिजे ते त्याला तुम्ही असाइन करू शकता. इथं बघा फॉर एक्झाम्पल परत एक्स स्क्वेअर कॉमा 9x² अशी दोन फंक्शन्स घेतलेत आणि एक्सला मी रेंज दिली आहे -3 to +3. सो सी हिअर देर आर 2 प्लॉट्स. एक आहे ब्लू आहे आणि दुसरा आहे ऑरेंज. सो फर्स्ट आहे तो ब्लू, दिस x² प्लॉट आहे आणि 9x² हा एक प्लॉट आहे. सो यू कॅन अंडरस्टँड दिस 2 प्लॉट्स आर हिअर. सो बाय डिफॉल्ट त्यांना कलर त्यांचे काय हे होऊ शकते, जाऊ शकते. आता काय वेळा ती रेंज असतीये ती ऑटोमॅटिक आपण त्याला घ्यायला सांगू शकतो. फॉर एक्झाम्पल मी एक इथं फंक्शन टाईप केलंय तर त्याचं मला काय आउटपुट नको आहे, मी सेमिकोलन टाकलाय आणि काहीतरी त्याला या रेंजमध्ये व्हॅल्यूज घेऊन त्याचा प्लॉट मला इंटरेस्ट आहे आणि प्लॉट रेंज ऑटोमॅटिक वगैरे असं मी काहीतरी म्हणतोय. सो यू विल फाइंड दॅट समथिंग, यू विल गेट प्लॉट ऑफ दिस काइंड. आता हा प्लॉट जरा विचार करायला लावणार आहे. बेसिकली यू विल फाइंड दॅट दिस प्लॉट यू कॅन आस्क स्टुडंट की असा कसा दिसतोय, असं तुम्ही स्टुडंटना विचारू शकता. बघा हे जर मी एक्सप्रेशन बघितलं फंक्शनचं तर 1/(x - 3) आहे. डिनॉमिनेटर ज्यावेळी 0 होतोय त्यावेळी नॅचरली दिस फंक्शन टेन्स टू इन्फिनिटी. सो डिनॉमिनेटर 0 होण्याचा चान्स कुठं आहे तर x=3 ला डिनॉमिनेटर 0 होण्याचा चान्स आहे, ज्याला आपण डायव्हर्जन्स म्हणतो. सो या ठिकाणी डायव्हर्जन्स आहे. सो जर तुम्ही याला रेंज दिली x=3 घातलं तर स्ट्रेट वे इट विल टेंड टू इन्फिनिटी. त्यामुळे इन्फिनिटी वायचा इन्फिनिटी असा व्हर्टिकली सरळ दाखवलाय वाय ऍक्सिसला पॅरलल. आणि इथं जर तुम्ही ग्राफवर बघितला तर बरोबर या दोन कर्वच्या मध्ये सेंटरला 3 आहे. सो या बरोबर पॉइंटला तुमचं हे फंक्शन डायव्हर्ज होतं, इट ब्लोज आउट और इट गोज टू इन्फिनिटी. म्हणजे हे असं तुम्ही तिथला अल्जिब्रा आणि इथं प्लॉट मध्ये दिसणारी सिच्युएशन को रिलेट करू शकता. देर आर सो मेनी सच थिंग्स यू कॅन प्लॉट. इथं तुम्हाला खूपशे प्लॉट मी तुम्हाला जस्ट दाखवणार आहे. सिंगल कमांड आहे प्लॉट, से 10 sin x. दुसरा प्लॉट मी घेतला, समजा मी हे कॅन्सल केलं, सब cos x. आता साधी फंक्शन्स आहेत की ज्याचे प्लॉट माहित असणं आपल्याला नेट सेट एक्झाम किंवा मॅथमॅटिकल कॅल्क्युलेशन करत असताना किंवा अल्जिब्राइक इक्वेशन बघितल्यावर त्याचा प्लॉट कसा असेल फॉर दॅट मॅटर, हे तुम्ही विद्यार्थ्याला स्टुडंटला अगोदर गेस करायला सांगू शकताय. साइन एक्स बघा, इट स्टार्ट फ्रॉम 0. कॉस एक्स इनिशियली तो +1 असतोय किंवा 10 असणार आहे आपला, फॉर दॅट मॅटर इथं 10 cos x. तर त्याची अँप्लिट्यूड काय 10 आहे. सो वेव्ह मोशन सारख्या गोष्टी आपण करत असताना यू कॅन आस्क देम टू जनरेट सच काइंड ऑफ प्लॉट. आता आपण दोन वेव्ह सुपरपोज करतो तर यू विल फाइंड दॅट सुपरपोजिशन ऑफ प्लॉट इज ऑल्सो पॉसिबल. मी इथले इथे एक चेंज करून दाखवतो, 10 sin x + 10 cos x. मी असं काहीतरी घेतलं. सपोज मी हे फंक्शन हे केलं, कॉपी केलं आणि इथंच मी टाईप केलं. सपोज मी इथं टाईप केलं आणि मी सांगितलं की हे फंक्शन प्लॉट करून मला बघायचं आहे. सो यू विल फाइंड दॅट समथिंग यू विल गेट, सॉरी, amplitude थोड़ी change कर. For that matter, here I will do amplitude 5 and here I will do amplitude 50. So let's see what happens to this graph. Just a minute, I'll suppress this. Yeah, so I can type this into bracket. So I'll put them in a bracket. So this is thing. Now you will probably get it. Just a minute. Just a minute. I'll just adjust the brackets. 5 cos x. Output terminate here. 1 minute. Delete all output. Suppose here if I shall take tan or something, there are major changes this never. So look, here you have got a 5 cos x plus 50 tan x. याचा जर मी प्लॉट घेतला तर प्लॉटचं नेचर असं असतं. सो यू कॅन ऑल्सो हॅव अ कंपोजिट फंक्शन्स. पुष्कळ तुम्ही काय कोसेक असेल तर CSC, सेक असेल तर SEC, कॉट असेल तर COT, कॉट C कॅपिटल, प्रत्येक फंक्शनचं कॅपिटल आपण टाकतोय. हे सपोज मी टॅन नुसता प्लॉट केला, so you'll get this kind of a plot. So if you have this kind of a thing, बघा तर तुम्हाला बऱ्याच ठिकाणी ते प्लॉट्स, सुंदर प्लॉट्स तुम्हाला जनरेट करता येऊ शकते and you can plot them. So cotचा प्लॉट मी बघितला. See, this is a plot for cot. Here, this is for cot. Tanचा इनवर्स असतो तो, so you will get for plot. So this kind of certain things are there. जर तुम्हाला हे सगळेच्या सगळे प्लॉट्स एका ग्रिड मध्ये पाहिजे असतील किंवा एका विंडो मध्ये दिसायला पाहिजे असतील तर हे सगळी मी फंक्शन्स G1, G2, G3 वगैरे जे का आहेत ती काय केलेत, सगळी या ऍड्रेसेस मध्ये स्टोअर केलेत. आणि मी म्हटलं की शो G1, G2. आता मी फक्त दोनच त्यातले मला पाहिजे आहेत, तर आय जस्ट डिलीट ऑल प्लॉट्स, डिलीट ऑल आउटपुट. ओके, and I will show you this thing. For example, G1, G2, G3, G4 वगैरे असे मी सगळे ऍड्रेसेस क्रिएट केले अप टिल 7. आणि मी म्हटलं की जस्ट हॅव दिस इनपुट आणि मला मग काय करायचं आहे, सगळे एका विंडो मध्ये बघायचे आहेत. तर आय कॅन हॅव ऑल दिस मल्टिपल प्लॉट्स इन दिस विंडो. या पद्धतीने तुम्ही बघू शकता. सो हे प्लॉट्स तुम्हाला दिसतील, ग्राफ ग्रिड्स. हे मी जर आउटपुट याचं काढून टाकलं तर तुम्हाला हे पण प्लॉट्स दिसतील. यू विल गेट ऑल दिस प्लॉट्स. हे बघा, ओ हो खूप लांब गेले ते. हा इथं हे बघा, ऑल दिस प्लॉट्स आर जनरेटेड. नाउ सी, आता मी ज्याचं आउटपुट सप्रेस केलेलं नाही ते असे आहेत G1, G2, G3, G4, G7. आणि हे बघा, हे 1 2 3 4 5 6 7. You can see this. ही मी विंडो तुम्हाला मोठी करून दाखवू शकतो. I can show you these multiple plots. तर हे सगळे साती प्लॉट्स G1 G2 to G7 पर्यंतचे सगळे याच्यामध्ये आलेले. सो यू कॅन हॅव दिस मल्टिपल प्लॉट्स. आता ते तुम्ही त्याचे ग्रुप करून घेतले. फॉर एक्झाम्पल G1 G2 चा एक ग्रुप, G3 G4 चा एक ग्रुप, G5 G6 चा एक ग्रुप. तर तुम्ही हे असे ग्रुप करून पण घेऊ शकता. 1 2 3 4 5 6. सो यू कॅन हॅव ऑल दिस प्लॉट्स. यू कॅन अरेंज देम. सगळ्या फॅसिलिटीज तुम्ही या मॅथमॅटिकातून क्रिएट करू शकता. आणि दुसरी गोष्ट, हे सगळे तुम्ही प्लॉट जर तुम्ही बघितलं तर रिसर्चला वगैरे मी सेव्ह ॲज सच केलं तर त्याला तुम्ही सगळ्या वेगवेगळ्या फॉर्मॅट्स मध्ये सेव्ह ॲज करू शकता. म्हणजे PNG असेल, टिफ असेल, PDF असेल, कुठल्याही फॉर्मॅट मध्ये मॅथमॅटिका तुम्हाला सेव्ह करायचा चान्स देते. सो यू कॅन हॅव दिस मल्टिपल प्लॉट्स. आता मला समजा की या काही बेसिक एकदम साध्या सोप्या गोष्टी मी तुम्हाला शिकवतो. एकदम सिंपल साध्या काही गोष्टी आहेत. आता मला समजा की याच्यातली एखादी कमांड आहे आणि त्याच्याबद्दल माहिती पाहिजे. आय डोंट नो एनिथिंग अबाउट दॅट. तर हे मॅथमॅटिकाचा हेल्प मेनू खूप स्ट्रॉंग आहे. इथं गेला तुम्ही वुलफ्रॉम डॉक्युमेंटेशनला गेला तर तुम्हाला इथं कुठल्याही गोष्टीबद्दल मिळू शकतंय. प्लॉट मी असं टाईप केला तर यू कॅन सी हिअर नंबर ऑफ थिंग्स. प्लॉट हे फंक्शन कसं आहे, त्याची कमांड कशी लिहायची हे तुम्ही बघू शकता. एम आय ऑडिबल? ऐकू येतंय का?
Yes, sir.
ऐकू येतंय ना?
Yes.
ओके. दिसतोय स्क्रीन व्यवस्थित?
Yes, screen is also visible.
ओके फाईन. तर तुम्ही असं त्याचा हेल्प मेनू आहे, तिथून तुम्ही प्लॉट ही कमांड कशी आहे, कशी वापरायची हे सगळं तुम्ही बघू शकता. त्याची खाली एक्झाम्पल असते, कॉपी करून तुम्ही हे करू शकता, ती प्लॉट करू शकता. सपोज मी इथलं एक घेतलं, हे कॉपी करून एक्झाम्पल, आणि मी इथंच एखादं प्लॉट केलं. सपोज इफ आय शॅल डू इट हिअर, मी कॉपी पेस्ट केलं, हे मी केलं सपोज, आणि मी म्हटलं प्लॉट, तर यू विल फाइंड दॅट दिस प्लॉट इज दॅट. सो यू कॅन हॅव मल्टिपल प्लॉट, sin x, sin 2x, sin 3x सगळे तुम्ही इथं बघू शकता. त्याला लिजेंड्स, प्लॉट लिजेंड्स नावाचं आपण त्याला ऑप्शन क्रिएट करून देऊ शकतो. आणि एक्सप्रेशन म्हटलं तर ते जे जे फंक्शन आपण प्लॉट केलंय ते त्या कर्वला ते लिजेंड म्हणून जाऊ शकतं. सो ऑल दीज फॅसिलिटीज आर अवेलेबल इन मॅथमॅटिका. मी अतिशय थोड्या दाखवायला लागलोय. तुम्ही ऍक्सेस लेबल करू शकता किंवा हेल्प मेनू मध्ये जाऊन तो काय आहे कमांड बघू शकता. फॉर एक्झाम्पल मी इथं ऍक्सेस लेबल ही कमांड वापरायची ठरवली, तर इथं बघा व्हॅल्यू ऑफ ऍक्सेस, व्हॅल्यू ऑफ एक्स आणि व्हॅल्यू ऑफ साइन एक्स, या इथं मी त्याला ऍक्सेस लेबल देऊ शकतो. प्लॉट लिजेंड्सला आपण खूप काही गोष्टी करू शकतो. फॉर एक्झाम्पल प्लॉट लिजेंड्स ऑटोमॅटिक म्हटलं तर 1 2 3 असे लिजेंड्स पडते. प्लॉट लिजेंड एक्सप्रेशन म्हटलं तर ती जी काय फंक्शन्स आहेत ती त्याला एक्सप्रेशन्सला, त्या फंक्शन्सला जाऊ शकते. प्लॉट लिजेंड्स मध्ये तुम्ही स्टाईल देऊ शकता, त्याला कलर देऊ शकता. सो यू कॅन हॅव दॅट काइंड ऑफ अ थिंग. आणि ते तुम्ही दिलं तर तुम्हाला लक्षात येईल की तुम्ही या सगळ्या गोष्टी कलर कस्टमाइज करू शकता. सो यू कॅन कस्टमाइज कलर फॉर दॅट. हे बघा, यू कॅन गिव्ह कलर्स टू दॅट. म्हणजे तुम्हाला ज्या पद्धतीने पाहिजे त्या पद्धतीने तुम्ही कस्टमाइज करू शकता. सो तुम्हाला फ्रेम पाहिजे असेल तर ठेवू शकता किंवा घालवू शकता. सो हिअर सी ऍक्सेस फॉल्स, इथं ऍक्सेस दिसायचे बंद झाले. यू डोंट हॅव ऍक्सेस हिअर. यू कॅन हॅव अ फ्रेम. फ्रेम ट्रू म्हटलं तर फ्रेम दिसतीये, ऍक्सेस फॉल्स म्हटलं तर ऍक्सेस दिसायचे बंद होते. फॉर एक्झाम्पल इथं फ्रेम फॉल्स आणि ऍक्सेस ट्रू म्हटलं तर बरोबर उलट होत आहे. हे बघा. सो यू कॅन कस्टमाइज दिस 2D प्लॉट्स बाय नंबर ऑफ थिंग्स. आता फिलिंग हा एक ऑप्शन दाखवतो. सी, फिलिंग इज अ वन काइंड ऑफ ऑप्शन. सो मी म्हटलंय फिलिंग राईट फ्रॉम ऍक्सेस. मी 1 - x² एक फंक्शन प्लॉट केला बिटवीन द रेंज -1 to 2. आणि फिलिंग म्हणजे कर्वचा खालचा एरिया असतोय तो तुम्ही फिल करू शकता. आता मल्टिपल कर्व्स असतील, एकापेक्षा जास्त, इथं ही वी हॅव 3 कर्व्स, 1 - x², 2 - 2x², 3 - 3x², आणि ते आपल्याला फिलअप करायचे आहेत. तर यू कॅन गेट दिस काइंड ऑफ अ फिलिंग. तर तुम्हाला ते कर्व्स ओव्हरलॅप होत असतील तसे सेपरेट करता येतात. सो यू कॅन ऑल्सो असाइन कलर्स टू इट. हे बघा, तुम्ही कलर सुद्धा असाइन करू शकता त्याला. येलो, ग्रीन, ऑरेंज. सो हिअर ऑरेंज, हिअर ग्रीन अँड हिअर येलो. तुम्ही त्या पद्धतीने त्याला कलर्स असाइन करू शकता. आता जास्त मी काय कमांड्सचे डिटेल्स सांगत नाहीये, कारण तर हँड्स ऑन एक्सपिरियन्सला या सगळ्या गोष्टी तुम्हाला सांगता येतात. बट बिकॉज ऑफ टाइम कन्स्ट्रेंट मी आता ह्या सगळ्या गोष्टी तेवढ्याच छोट्या दाखवतोय. सी एक्स स्क्वेअर मायनस एक्स स्क्वेअर एक्स स्क्वेअर साइन 10x अशी 3 फंक्शन्स आहेत. -2π to +2π मध्ये मी ते प्लॉट केलेत. आणि हे जर सगळे आपण घेतली फंक्शन्स तर तुम्हाला इथं काय काय रिझल्ट आहेत ते मिळतात. हे एक असा ब्लू कर्व आहे, एक ऑरेंज कर्व आहे आणि एक ग्रीन कर्व आहे ऑसिलेटरी. सो यू विल फाइंड दॅट दोज थिंग्स आर देअर. आता बघा हे एक्स स्क्वेअर साइन 10x याची जी अँप्लिट्यूड आहे ते अँप्लिट्यूड मॉड्युलेशन सारखी झालेली दिसतीये. सो इट इज समथिंग लाईक दॅट. जर क्वांटम मेकॅनिक्स मध्ये गेला तुम्ही नंबर ऑफ वेव्ह फंक्शन्स ओव्हरलॅप करून वेव्ह पॅकेट वगैरे कसं तयार होत आहे किंवा फ्रिक्वेन्सी मॉड्युलेशन अँप्लिट्यूड मॉड्युलेशन कसं होत आहे ते बघू शकता. आता मॅथमॅटिकामध्ये खूप प्रकारचे प्लॉट्स आहेत, म्हणजे खूप वेगवेगळ्या पद्धतीने तुम्ही प्लॉट करून बघू शकता. पॅरामेट्रिक प्लॉट असतात, कंटूर प्लॉट असतात, पोलर प्लॉट असतात. आपण फोटो सेलचा एक्झाम्पल घेतो प्रॅक्टिकलला, त्याच्यात पोलर प्लॉट काढतो, म्हणजे फोटो सेल ठेवतो आणि सर्क्युलर पाथवर त्याचा अँग्युलर व्हेरिएशन घेऊन आपण काही वेळा त्याचं इंटेन्सिटी कशी चेंज होतीये ती बघतो फोटो सेल मध्ये. तर हे सगळे प्लॉट्स इथं तुम्हाला दिसतील, इथं काढता येतात आपल्याला पॅरामेट्रिक प्लॉट. हे जे एक्सप्रेशन आहे याच्यामध्ये टी ला पॅरामीटर ट्रीट करून, 2 आहेत हे फंक्शन्स, यामध्ये टी ला पॅरामीटर ट्रीट करून त्याला एक रेंज दिली आणि फ्रेम ट्रू म्हटलंय, तर तुम्हाला हा असा कर्व निघतोय. सो इथं सुद्धा तुम्हाला म्हणजे तुम्ही जर वेगवेगळ्या गोष्टी फॉर एक्झाम्पल प्रोजेक्टाईल मोशन किंवा कायनेमॅटिकल इक्वेशन्स याचे प्लॉट एकदम सिंपल प्रकार आहे याच्यामध्ये. यू कॅन हॅव अ नंबर ऑफ प्लॉट्स फॉर दॅट, काढू शकता ते. इथं मी 2 दिलेत, एक्स इज अ फंक्शन ऑफ टी, वाय इज अ फंक्शन ऑफ टी, आणि टी ला मी पॅरामीटर म्हटलं आणि पॅरामेट्रिक प्लॉट काढ म्हटलं तर इट कॅन गिव्ह यू पॅरामेट्रिक प्लॉट. हे बघा सी. सो माझा एक्स आहे कॉस टी मायनस कॉस ऑफ 100t साइन टी आणि वाय आहे 2 साइन टी मायनस साइन ऑफ 100t. मी याच्यात थोडा जरी चेंज केला तरी इथला प्लॉट तुम्हाला चेंज झालेला दिसेल. फॉर एक्झाम्पल मी इथं कॉस टी ला मी अँप्लिट्यूड ठेवली, सपोज 10 ही अँप्लिट्यूड ठेवली आणि मी म्हटलं पॅरामेट्रिक प्लॉट काढ, तर यू विल गेट दिस काइंड ऑफ अ पॅरामेट्रिक. सो जे काय चेंजेस आहेत ते तुम्ही साध्या सिंपल फंक्शन मध्ये डिक्लेअर केले तर त्याचा रिझल्टंट आउटपुट असतो तर पटापट फास्ट तुम्हाला इथं दिसतोय. आणि रिसर्च लेवलला गेला तर या प्रकारचं टूल असणं आवश्यक असतं, म्हणजे ऍज फार ऍज दोज हु आर डुईंग कम्प्युटेशन दे नीड ऑल दिस काइंड ऑफ टूल्स, कम्प्युटिंग टूल्स फॉर दॅट. मी इथं जरी अँप्लिट्यूड कॉस्टची 100 केली तरी सुद्धा तुम्हाला पॅरामेट्रिक प्लॉट मध्ये चेंज झालेलं दिसेल, किती छोटा झाला बघा. सो इन्स्टेड ऑफ 10 100 मी अँप्लिट्यूड कमी केली तर मी अजून चांगला प्लॉट झालेला दिसतोय. सो यू विल गेट दिस काइंड ऑफ अ प्लॉट. सो यू जस्ट मेक अ चेंजेस ओव्हर हियर. तुम्ही या ठिकाणी चेंजेस केला, याला मी 2 ला 20 केलं. आता मी आर्बिटरी करायला लागलोय चेंजेस, तुम्ही ठरवून करू शकता चेंजेस. हे बघा प्लॉट हॅज बीन चेंज. सो यू कॅन सी सच मल्टिपल चेंजेस. इथं मी साईनला केलाय मी चेंज, इथं साईनला मी अँप्लिट्यूड सपोज घातली 10 आणि मी म्हटलं चला काय चेंज होतोय बघूया. सो यू विल फाइंड अ चेंज ओव्हर हियर. सो यू कॅन हॅव सच चेंजेस इन युअर फंक्शन. त्या पद्धतीनं तुम्ही करून बघू शकता चेंजेस, आणि तुम्हाला जे काय प्लॉट्स असतील त्या प्लॉट्स मधले चेंजेस सुद्धा करता येतात. सो दिस इज पॅरामेट्रिक प्लॉट. हा पॅरामेट्रिक प्लॉट, टी हा त्याचा पॅरामीटर आहे आणि त्याला एक रेंज दिलेली आहे ती 0 to 2π आणि फ्रेम ट्रू म्हटलंय. ऍक्सिस वगैरे काय तुम्हाला ते बाय डिफॉल्ट जे दिसतील ते. आता कंटूर प्लॉट सुद्धा हा एक प्रकार आहे. सपोज एक्स स्क्वेअर वाय स्क्वेअर इक्वल टू वाय प्लस 1 ब्रॅकेट स्क्वेअर 4 मायनस वाय स्क्वेअर, आणि एक्स ला रेंज दिली, वाय रेंजला दिली, आणि मी इथं हे कमांडचे फार डिटेल्स मी सांगत नाही. अस्पेक्ट रेशो म्हणजे काय, ऍक्सिस आणि फ्रेमचं मी सांगितलंय तुम्हाला. सो यू विल सी हिअर कंटूर प्लॉट आला. दिस इज कंटूर प्लॉट. Contour plot. See here also you can have a contour plot for that. These are contour plots. कंटूर म्हणजे आपल्याला माहित आहे की पूर्वी आपण जिओग्राफीच्या पुस्तकामध्ये वगैरे हरित जंगल, तर ते सगळे स्पॉट कनेक्ट करणारा एक लाईन काढतो, दॅट स्टँड्स वन कंटूर. किंवा एक टेम्परेचर रेंज घेतली किंवा पावसाचा रेनफॉल घेतला, तर ते सगळे पॉइंट्स मॅपवरचे कनेक्ट करणारे एक प्लॉट काढतो, दॅट्स अ कंटूर. पोलर प्लॉट काढतो आता. पोलर प्लॉट्स आर ऑल्सो इंटरेस्टिंग. सो हिअर यू विल गेट पोलर प्लॉट्स. सी, दिस इज पोलर प्लॉट. हा कार्डॉइड म्हणतो त्याला आपण, हार्टचा शेप सारखा दिसतो. हा मी दुसरा एक पोलर प्लॉट घेतला सपोज, तर यू विल फाइंड दॅट दिस इज वन मोर पोलर प्लॉट. सी, याच्यामध्ये तुम्हाला माहित आहे की मी काय रेंज दिलंय, व्हेरिएशन काय दिलंय बघा तिथं. तर पोलर प्लॉटला 1 sin 3 theta and theta varies from 0 to 2 pi हे दिलंय रेंज. सो यू विल फाइंड दॅट इन दिस रेंज यू कॅन हॅव दॅट पोलर प्लॉट. मी 2 pi च्या ऐवजी पाय घेतला आणि सपोज व्हॉट विल बी माय पोलर प्लॉट, तर यू विल गेट दिस पोलर प्लॉट. खालचा हा सेमी सर्कल काय झालाय, कट झालाय आणि यू विल हॅव ओनली 3 पेटल्स. मग मी साइन फंक्शन मध्ये सुद्धा चेंज करून बघू शकतो. 3 इथं ठेवलंय म्हणून 3 मला पेटल्स मिळाले, त्याच्याऐवजी मी 10 ठेवलं आणि प्लॉट इथं परत रेंज मी 2 पाय केली, तर माझा पोलर प्लॉट काय होतोय, तर शॅल आय गेट 10 पेटल्स, आय विल गेट 10 पेटल्स. सो पोलर प्लॉट्स यू कॅन जनरेट जस्ट बाय ऍडजस्टिंग फंक्शन्स. तुम्ही हे चेंजेस करून बघू शकता. ज्यांना असं व्हिज्युअल गोष्टी बघायची इच्छा असते, काय फंक्शन मध्ये चेंज केला, इकडे काय होतोय, लगेच इमिडिएट तुम्हाला प्लॉट जनरेट होते. सो यू कॅन हॅव दिस काइंड ऑफ थिंग्स थ्रू व्हेरियस थिंग्स ऑफ कस्टमायझेशन. म्हणजे ज्याला आपण, मी आता 100 पेटल्स करायचे ठरवल्या, तर आय विल हॅव 100 पेटल्स ओव्हर देअर. सी, 100 पेटल्स झाले. यू कॅन सी हिअर 100 पेटल्स. सो इट्स नॉट अ बिग इश्यू की साध्या साध्या गोष्टी असतात, तुम्ही करून बघू शकता. हिअर यू कॅन कस्टमाइज इट बाय नंबर ऑफ वेज. कुठं चेंज केल्यावर काय चेंज होतं तुम्ही बघू शकता. यू कॅन सी दॅट चेंजेस. सी, 50 पेटल्स. सो यू हॅव डन 50 पेटल्स. इझिली तुम्हाला जर रिझॉल्व्ह व्हायचं बघायचं असेल, आय कॅन कीप हिअर 5 पेटल्स. सो इन दिस पोलर प्लॉट यू विल गेट 5 पेटल्स. 5 पेटल्स. सो सच थिंग्स आर पॉसिबल. आता खूप सांगण्यासारखं आहे. एक 10 मिनिटात मी तुम्हाला काही स्पेशल प्लॉट आणि अॅनिमेशन्स दाखवतो. हे काय बार चार्ट वगैरे काढता येते, फॉरगेट दॅट. मी आता इथं काही अॅनिमेशन्स करून दाखवतो. फॉर एक्झाम्पल ही एक अॅनिमेशन्स, तर त्याची कमांड आहे अॅनिमेट. सो अॅनिमेट इज अ कमांड यूज फॉर दॅट. आता मला एक फंक्शन प्लॉट केलंय मी, x raised to k. x ला रेंज दिली आहे -1 to +1. प्लॉट रेंज त्याची ठेवली आहे -1 to +1. टिक्स फॉल केलेत आणि k हा जो आहे तो पॅरामीटर मी 1 पासून 19 पर्यंत व्हेरी केलाय विथ द स्टेप साइज ऑफ 2. 1, 3, 5, 7, 9, 11 या पद्धतीनं ऑड घेतलाय आणि तो 19 पर्यंत गेलाय. आणि मी हा प्लॉट आता काय करतो, इथल्या इथं हे करून दाखवतो. खूप खाली जायला नको. सो आय हॅव नाउ ब्रोकन द सेल. शिफ्ट कंट्रोल D दाबलं की तुमची सेल तेवढीच ब्रेक करून घेता येते आणि इथं हा प्लॉट. सो कॅन सी जशी k ची व्हॅल्यू बदलेल तसा तुमचा प्लॉट कसा अॅनिमेट होतोय ते दिसतं. सो यू कॅन अॅनिमेट दिस प्लॉट्स. मग हवं तर तुम्ही इथं 0 पासनं इव्हन नंबर्स घेतले, 0 पासनं समजा मी 20 पर्यंत घेतले, तर काय होतंय असं बघायचं असेल तर यू कॅन हॅव दिस चेंज फ्रॉम 0 to 20. आणि मग बघा पॉवर त्याची इव्हन ठेवली की तो पॅराबोलिक असतोय आणि जसा k बदलेल, k ची पॉवर बदलेल तसा तो फ्लॅटन व्हायला लागतो ऍट द बॉटम. सो यू कॅन अॅनिमेट प्लॉट. दिस इज इझिली पॉसिबल. सो यू कॅन स्टॉप इट हिअर. पॉज आहे. समजा एका विशिष्ट मोमेंटला तुम्हाला पॉज करायचं आहे, पॉज करू शकता. तुम्हाला फास्ट करायचं आहे हे अॅनिमेशनचं स्पीड, सो यू कॅन इन्क्रीज इट्स स्पीड अॅनिमेशनचं. If you want to decrease its speed, you can slow down. You can also slow down. And if you want to do backward and forward, इथं फॉरवर्ड मोशन पण आहे, बॅकवर्ड मोशन पण आहे. सो बॅकवर्ड सुद्धा तुम्ही बघू शकता. आणि इथं फॉरवर्ड बॅकवर्ड दोन्ही आहे. सो लास्ट फॉरवर्ड बॅकवर्ड चेंजेस करू शकता. राईट फ्रॉम 0 to 20, फ्रॉम 20 to back to 0. सो सगळ्या प्रकारची अॅनिमेशन्स तुम्ही प्लॉटला देऊ शकता. This kind of a thing is possible through Mathematica, which is a simple command for that is animate. Just say animate. So you will get everything that मॅनिप्युलेट नावाची एक कमांड आहे. आता आय विल स्टॉप दिस. इथं मॅनिप्युलेट नावाची एक कमांड आहे. तर इथं काय केलंय बघा आपण. मी आय विल डिवाइड दिस सेल फर्स्ट ऑफ ऑल, शिफ्ट कंट्रोल डी. So here you will find that plot x raised to k, x raised to -1 to +1, plot range तेच आहे, टिक्स फॉल आहेत आणि वरचीच कमांड आहे, फक्त त्याला कमांड ॲनिमेटच्या ऐवजी मॅनिप्युलेट म्हटलं. सो व्हॉट विल हॅपन हियर. आता बघा इथं तुम्हाला के करता बार दिसतो. हियर यू विल फाइंड अ बार फॉर के क्रिएटेड आणि इथं जाऊन तुम्ही ऑटो रन म्हटलं की इट स्टार्ट्स रनिंग. ओके, सो दिस इज हाऊ इट वर्क्स. इथं तुम्ही क्लोज करू शकता, परत इथं जाऊन तुम्ही काय करू शकता, ऑटो रन करू शकता. सो इथं मी ते मगासप्रमाणे त्याची रेंज 0 to 20 केली सपोज अँड स्टेप साइज 2 ची ठेवली, तर यू विल ऑल्सो गेट दॅट काइंड ऑफ थिंग विच यू हॅव ऑब्झर्व्ड जस्ट नाव. नाव फॉर दॅट यू विल हॅव टू ऑटो रन. हे बघा त्या के ची प्रोग्रेस जशी होतीये तसं तुम्हाला कळतंय आणि हवं तर बॅकवर्ड फॉरवर्ड आणि फॉरवर्ड बॅकवर्ड दोन्ही बघू शकता तुम्ही. के मध्ये होणारे चेंजेस झाले, के प्रोग्रेसिव्हली वाढत गेला, के प्रोग्रेसिव्हली कमी होत गेला, तर होणारे कर मधले चेंजेस तुम्हाला मॅनिप्युलेट कमांड मध्ये मिळू शकतात इथं. आणि इथं बघा त्याला रेडिओ बटन सुद्धा घालता येत आहे. जस्ट दिस फॅसिलिटी इज देअर. कॅन पुट अ रेडिओ बटन फॉर दॅट. इथं ऑप्शन आहे बघा शेवटी रेडिओ बटन म्हणून. सो यू कॅन हॅव दिस थिंग्स ओव्हर हिअर. ही रेडिओ बटन सारखं तुम्ही इथं त्याला ऑप्शन्स घालू शकता. सो के कसा प्रोग्रेस होतोय ते कळतंय. तुम्हाला एका विशिष्ट केला गेल्यावर थांबवायचं असेल तर थांबवू शकता.
Hello. Hello.
Hello, is there range problem?
सर बहुतेक डिस्कनेक्ट झाले, रेंजचा प्रॉब्लेम आला सरांना.
Okay,
मिनिटं वेट करू, 5 मिनिटं.
okay.
दोंगडे सर जॉईन होत आहेत का?
एक कॉन्टॅक्ट चाललंय सरांना करायचा, 1 मिनिट थांबा.
ठीक आहे ठीक आहे.
सर जॉईन करून घ्यायचे.
सरांना कनेक्टिव्हिटी मिळत नाही का? हॅलो. मॅडम सरांना फोन केला ना?
Yes, sir.
काय स्टेटस काय?
मग ते त्याची
Sir is joining from mobile. Please wait for 2 minutes.
ओके.
हॅलो मॅडम.
Hello. Yes, sir.
हा एक 2 मिनिटं अजून घेतो. किती घेऊ? वेळ देताय मला? 1 2 मिनिटं 5 मिनिटं?
Yes, sir. No problem.
चालेल.
तुमचा वेळ किती पाहिजे तेवढा घ्या सर.
अं,
एक 2 टाइम.
चालेल. ओके. So there are a couple of commands that we have seen, animate and manipulate. आता एक 3-dimensional plot जे असते, those are also quite interesting. Am I audible, ma'am? Hello?
Yes, sir.
No problem. Okay.
No
So
problem.
3D plots are also an interesting thing which you can enjoy. मुलांना जर एक व्हेरिएबल असेल इंडिपेंडंट तर 2-dimensional प्लॉट असतात आणि आपल्याकडे दोन जर इंडिपेंडंट व्हेरिएबल असतील तर आपल्याला 3-dimensional प्लॉट असतात. तर मी इथं sin x प्लस sin y आणि x ला -4 to +4 पाय रेंज दिली आहे, y ला पण
Sir,
-4.
please share your screen.
Oh yes, wait a minute. Am I not visible? Share your screen. Yeah, done. This time? Is it all right?
Yes, sir.
So here
Okay,
is a 3D plot, plot 3D. So this is my command. Sin x plus sin y, x आणि y ला रेंज दिली आहे आणि मेश फॉल्स म्हटलंय. आयडिया अशी आहे की एक व्हेरिएबल असेल तर 2-dimensional प्लॉट, दोन व्हेरिएबल्स असतील इंडिपेंडंट तर 3-dimensional प्लॉट. तर मी इथं एक सिंपल प्लॉट तुम्हाला दाखवतो पहिल्यांदा की what will be a 3D plot look like. So this plot you can see it change its orientation. हा प्लॉट आहे तो तुमचा 3-dimensional प्लॉट आहे. sin x एका ऍक्सिस वर आहे, sin y दुसऱ्या ऍक्सिस वर आहे. आता कुठल्या रेंज मध्ये आहे तर हवं तर तुम्हाला काय करता येतं, त्याची रेंज बदलता येते. सपोज y हा मी -2 पाय to +2 पाय केलं, so that you can understand की कुठे चेंज होतोय तो. So you will understand it here. एकाला रेंज आहे बघा, रफली यू कॅन गेस 4 पाय म्हणजे 4 त्रिकम 12, म्हणजे हा जो आहे हा एक्स ऍक्सिसच्या अलॉंग आहे. दिस इज अलॉंग दिस ऍक्सिस, आतमध्ये गेलेला हा एक्स ऍक्सिसच्या अलॉंग आहे. आणि दुसरा आहे तो 2 पाय म्हणजे अराउंड 6 आहे, तो वाय ऍक्सिसचं व्हेरिएशन याच्या अलॉंग आहे. सो यू कॅन अंडरस्टँड हाऊ प्लॉट चेंजेस. सो यू कॅन हॅव ऑल्सो चेंजेस लाईक 8 पाय, -8 पाय to +8 पाय. सी वाय ऍक्सिसच्या अलॉंग तुम्हाला सायकल्स वाढलेल्या दिसतात. So you can see this number of cycles has been increased. 1, 2, 3, 4, 5, 6, 7, 8. So you can keep equal cycles along x along y. The number of cycles तुम्हाला change झालेल्या दिसेल. Is that clear to you this time? Hello, ma'am.
Yes, sir. Yes, sir. No problem.
दिसते plot दिसते.
हा
Yes.
दिसतंय sir.
So I can see extend the. Is it visible? Fine.
Yes, sir. No problem.
So you can change the number of cycles even along x and y. Suppose phi me dile ikada phi kele. So you can also find change in the number of cycles along the y-axis and x-axis. These plots are visible. So similarly, I can have this combined thing. Me x and y एकाच argument खाली घेतले. So this is my new plot, 3D plot. Sin x minus y आणि x आणि y ला मी रेंज दिलेली आहे. आणि if I shall plot this, you'll find this x आणि y एकाच ह्याच्या खाली दिली. So you'll find these plots. You can change its orientation. याला ऍक्च्युअली प्लॉट कसा दिसावा याला व्ह्यू पॉइंट पण तुम्ही देऊ शकता. म्हणजे ऑब्झर्व्हरची लोकेशन तुम्ही डिक्लेअर करू शकता की 1, 1, 1 पोझिशनला उभा आहे किंवा 1, -1, 2 ला उभा आहे ऑब्झर्व्हर. सो यू कॅन हॅव दिस नंबर ऑफ थिंग्स. प्लॉट पॉइंट सुद्धा तुम्ही कस्टमाइज करू शकता, किती पॉइंट्स तुम्ही प्लॉट करावेत. सो 3D प्लॉट मध्ये दॅट इज ऑल्सो पॉसिबल. प्लॉट पॉइंट्स 40. मेश ट्रू आहे. तुम्हाला ते वरचं जाळं दिसायला नको हवं असेल तर यू कॅन ऑल्सो कॉल फॉल्स अँड यू कॅन कॅन्सल दॅट. सो हिअर ऑल्सो मेश फॉल्स, त्याच्याऐवजी तुम्ही ट्रू म्हटलं तर वरती लक्षात येईल तुम्हाला. यू कॅन impose mesh over it. Here mesh false. So plot points 40. मी plot points ची संख्या वाढवली सपोज, म्हणजे नंबर ऑफ पॉइंट्स त्यातले विचारात घेतलेले सपोज 100 केले तर यू विल फाइंड अ चेंज इन द प्लॉट लाईक दिस. जास्त त्याचं रिझोल्युशन होत आहे. So if you resolve it by less, so you can understand how does it actually changes plot. ते बघा ते त्याला काय येते, चॉप्स व्हायला लागतात, म्हणजे नंबर ऑफ डेटा पॉइंट्स कमी झाल्यासारखं होत आहे. तेच जर डेटा पॉइंट्स तुम्ही 100 घेतले प्लॉट पॉइंट्स, तर ते फिनिश्ड प्लॉट्स दिसते. यू कॅन सी दोज प्लॉट्स फिनिश्ड. सो हिअर ऑल्सो यू कॅन हॅव एक्सपोनेन्शियल फंक्शन वापरून तुम्ही 3D प्लॉट क्रिएट करू शकता. मेश. सो हिअर यू हॅव मेश ट्रू प्लॉट 3D. ही मी इथं तुम्हाला इथल्या इथं एक करून दाखवतो. सो आय कॅन जनरेट दिस प्लॉट हिअर. जस्ट मेश म्हणजे फक्त जाळीचा प्लॉट. मेश ट्रू प्लॉट पॉइंट्स 40 प्लॉट स्टाईल फेस फॉर्म म्हणजे त्याचं फक्त सरफेस आहे तो विचारात घेतलाय. मी प्लॉट पॉइंटची संख्या वाढवली, सपोज 400 केली, तर यू विल फाइंड दॅट देयर इज अ चेंज इन अ प्लॉट. तर तुम्हाला ते जास्त हे झालेलं दिसेल. किंवा हे थोडा वेळ लागतोय बिकॉज दॅट इज लिटिल बिट कम्प्युटेशन करता. हे बघा प्लॉट पॉइंट्स 4 केले तर क्रूड म्हणजे एकदम रफ सरफेस जनरेट करताय. प्लॉट पॉइंट्स 40 केले तर बऱ्यापैकी तो प्लॉट तुम्हाला त्याचा शेप डिफाईन होतोय. प्लॉट पॉइंट्स मी समजा त्याच्यापेक्षा जास्त केले, सपोज 100 केले, तर यू विल फाइंड दॅट there is, and this also you can visualize a plot like this. तुम्ही बघू शकता. आता पॅरामेट्रिक प्लॉट पण तुम्ही देऊ शकता. आणि पॅरामीटर इथे एक मी हे ठेवलाय, पॅरामेट्रिक प्लॉट 3D. म्हणजे मगाशी नुसता पॅरामेट्रिक प्लॉट होता, आता 3D प्लॉट मी पॅरामेट्रिक करतो. तर याच्यामध्ये तुम्हाला काय दिसतंय बघा. व्हॉट विल यू फाइंड इट हिअर. सी cos t sin t t/4. तुम्ही जर हे बघितलं, तुम्हाला आठवतंय का बघा, चार्ज पार्टिकलची मोशन बघितली इलेक्ट्रिक आणि मॅग्नेटिक फील्ड खाली प्लाझ्मा जे शिकतात त्या लोकांना लक्षात येईल की अशा प्रकारचे स्पायरल किंवा हेलिकल मोशन तुम्हाला बघायला मिळते. रिव्होल्युशनरी प्लॉट सुद्धा तुम्हाला डेव्हलप करता येते इथं. सो यू कॅन हॅव ऑल्सो रिव्होल्युशनरी प्लॉट हिअर. सो विच वाय ऍक्सिस भोवती तुमचं रिव्हॉल्व केलेला आहे. रूट ऑफ एक्स नावाचा एक कर्व असेल, तो काहीतरी तो जनरेट केलाय म्हणजे फिरवलाय, रोटेट केलाय. सो तो रोटेट केल्यानंतर आपल्याला 3D प्लॉट कोन लाईक स्ट्रक्चर दिसतंय. पोटेन्शियल वेल वगैरे तुम्ही जनरेट करू शकता. स्पेरिकल प्लॉट सुद्धा तुम्ही करू शकता. फॉर एक्झाम्पल हिअर यू हॅव अ स्पेरिकल 3D प्लॉट. प्लॉट 3D 1 phi theta phi theta from 0 to 2 pi या पद्धतीनं स्पेरिकल 3D प्लॉट देऊ शकता. सो सच नंबर ऑफ थिंग्स आर देअर. आता डेन्सिटी प्लॉट हा इथे एक प्रकार आहे बघा. सो हिअर यू विल फाइंड डेन्सिटी प्लॉट. मी एक हा प्लॉट तुम्हाला इथल्या इथं जनरेट करून दाखवतो. डेन्सिटी म्हणजे त्या ठिकाणी फंक्शनची डेन्सिटी तुम्हाला बघायला येते. सो हिअर डेन्सिटी प्लॉट x² + y². हा एक डेन्सिटी प्लॉट मी इथं प्लॉट केलाय. हा मी इथं त्याची पॉवर जर चेंज केली तर यू विल फाइंड दॅट हॅज बीन लिटिल बिट चेंज. तो चेंज होऊ शकतो, चेंज झाला. यू विल फाइंड दॅट चेंज इन द डेन्सिटी प्लॉट. सो या पद्धतीनं तुम्ही चेंजेस करू शकता. डेन्सिटी प्लॉट इथं सुद्धा तुम्हाला काढता येते. सो यू विल हॅव अ नंबर ऑफ थिंग. आता बहुतेक झालेला आहे. मी फक्त फिजिक्स मधले 2-3 गोष्टी दाखवतो, 3 प्रॉब्लेम्स की फिजिक्स मध्ये कुठं वापरता येतं. आता बोबडे सर तुम्ही बघा, सगळे फॅकल्टी बघा, डबल स्लिट डिफ्रॅक्शन इंटेन्सिटी जी आहे ती आपण या फॉर्म्युल्याने देतो. ऑप्टिक्स मध्ये डबल स्लिट इंटरॅक्शन डेन्सिटी या पद्धतीने देतो. तर ही ऍक्च्युली आपल्याला मॅथमॅटिकामधनं सिम्युलेट करता येते. यू कॅन सिम्युलेट दिस 3D डेन्सिटी. हे बघा हिअर जे बँड्स असते ते तुम्हाला दिसते. सेंट्रल मॅक्सिमा यू कॅन सी, आणि आयदर साइडला त्याचे इंटेन्सिटी पीक तुम्हाला कमी 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 होत गेलेले, हाईट कमी 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 होत गेलेली दिसते. सो यू कॅन सी दॅट. मी स्क्रीन जरा ढकलतो. सो यू कॅन सी सेंट्रल मॅक्सिमा आणि आयदर साइडला तुम्हाला 3D प्लॉट जनरेट झालेले दिसतोय. सो डबल स्लिट डिफ्रॅक्शनचा पॅटर्न तुम्हाला असा दिसतोय. व्हेरेवर यू कॅन चेंज इंटेन्सिटी, एम्प्लिट्यूड, तुम्हाला काय पाहिजे आहे ते चेंज करू शकता. सो अकॉर्डिंगली यू कॅन सी बीटाला व्हेरिएशन दिलाय sin बीटा स्क्वेअर डिवाइडेड बाय बीटा स्क्वेअर -2 to +2 आणि गॅमाला हा जो आहे त्याला पण
theta.
दिलाय. सो यू कॅन सी दिस -2 to +2 हे बघा या रेंज मध्ये. सो हा फॉर्म्युला आपण इंटेन्सिटीचा बघितला तर तुम्हाला ऑप्टिक्स मध्ये डबल स्लिट इंटेन्सिटी डिफ्रॅक्शनचा फॉर्म्युला डबल स्लिट डिफ्रॅक्शन इंटेन्सिटी तुम्ही जनरेट करू शकता. असं व्हेरिएशन आणि असं व्हेरिएशन यू कॅन अप्लाय फॉर इट. नंतर सिंगल स्लिट डिफ्रॅक्शन पॅटर्न आपण सुद्धा जनरेट करू शकतो. हे बघा म्यूट. हॅलो
Hello, sir.
हा
Yes,
सर
sir.
दिसतंय का?
Nice.
Yes.
Screen नाही दिसत, sir.
Screen. Please share your screen.
ओके कुठून बरोबर आहे? कुठून स्कॅन करू स्क्रीन? स्क्रीन शेअर करायचं कुठं? I'm not getting it. हो खरं इथं दिसत नाहीये ना. ओके विजिबल आहे का?
हा.
So this is sir single slit diffraction pattern.
Ha.
See here central maxima. This is the expression for intensity single slit chi. And here you have a diffraction pattern for this. You can simulate through this function. You can plot it. That is two-dimensional. Intensity is a function of beta, and beta la variation me dila hai -50 to +50. So all these intensity peaks slowly decreasing as you move away from the axis. A central maxima आहे. So ज्यावेळी बीटा तुमचा -50 to +50 मध्ये 0 होतोय त्यावेळी तो इन्फिनिटीला रीच होतोय. सो त्यामुळे ते लाईन्स पॅरलल गेले. सो यू कॅन फाइंड इट. इथं पी टॅलॉन ट्रान्समिशन कोएफिशियंट मी एक प्लॉट करून दाखवलाय. सो हियर यू कॅन प्लॉट इट. झाले एक 2 एक्झाम्पल आहेत सर विच यू कॅन. सो फॅब्रिक पॅराटिटलॉनचा इंटेन्सिटी जी काय ट्रान्समिशन कोएफिशियंट तो इथं प्लॉट केलाय आणि इथं त्याच ते हा जो कर्व दिसतोय समोरचा सरफेसचा हा तो मी इकडं 2D मध्ये काय केलाय सिम्युलेट केलाय. सो सच एक्झाम्पल्स यू कॅन शो फॉर फिजिक्स स्टुडंट्स की चला डबल स्लिट आहेत. यू कॅन एक्सटेंड दिस फॉर यन स्लिट्स. म्हणजे जर ग्रेटिंग सारखं घेतलं आपण यन स्लिट तर यनला पॅरामीटर ट्रीट केला तर यनला एक रेंज देऊन आपण एक 50,000 लाईन्स 50,000 लाईन्स वगैरे असं देऊन या पद्धतीने तुम्ही काय करू शकता सिम्युलेट करू शकता. सो दीज आर सम सिंपल एक्झाम्पल्स फ्रॉम फिजिक्स पॉइंट ऑफ व्ह्यू की मॅथमॅटिका फिजिक्स मध्ये कशी आपण एम्प्लॉय करू शकतो. So these are certain things which I have shown you, just an introductory sort of thing that I'm telling you. But this is how Mathematica actually helps to study physics. आता ते काय बाकीचं डिफरन्शियल इंटिग्रल वगैरे मी काय दाखवत नाहीये because of time constraint. So I will stop it here. These are a couple of examples that I would like to show you. Generally सगळ्यांना ग्रॅज्युएशनच्या मुलांना माहिती असतंय सिंगल स्लिट डबल स्लिट डिफ्रॅक्शन, त्यामुळे मी जनरली हे दोन एक्झाम्पल्स दाखवतो. So thank you, sir.
Thank
Quite
you
happy,
very much.
but sorry for the interruption from my end. म्हणजे माझ्याकडे युनिव्हर्सिटी कडूनच थोडंसं नेट कनेक्टिव्हिटी करता इश्यू आला. So sorry for interruption, but this is how actually Mathematica work. आणि मुलांना ते एकदा सवय लागली की चेंजेस करून बघायची. They can enjoy this.
Yes.
Thank you, sir. Tapase sir, thank you.
क्वेश्चन्स कोणाला विचारायचे?
So anyone wants to ask questions? की काय प्रश्न असतील तर विचारा. You can ask me. बहुतेक कुणाला क्वेश्चन्स आहे?
हे ओपन ऍक्सेसच आहे की नाही सर सॉफ्टवेअर?
नाही आहे सर, ओपन ऍक्सेस नाही आहे. दिस इज लायसन्स सॉफ्टवेअर.
लायसन्स. अच्छा.
खरं सर याच दर्जाची काम करणारी ओपन सोर्स पण आहेत. उदाहरणार्थ सर सेज म्हणून एक सॉफ्टवेअर आहे विच इज इक्वली गुड जस्ट लाईक मॅथमॅटिका. सेज. पायथॉन आहे, पायथॉन मधनं सुद्धा तुम्ही अॅनिमेशन सिम्युलेशन करू शकता.
ओके.
तर या प्रकारची सर ओपन सोर्स सॉफ्टवेअर जर मुलांना आपण ग्रॅज्युएशनला इंट्रोड्यूस केली ऍड ऑन कोर्स म्हणून.
अच्छा.
कारण काय आपल्याकडे बेसिकली सर मुलं प्लेन शिकत असतात, म्हणजे ग्रॅज्युएशन तर प्लेन ग्रॅज्युएशन, त्याला साइड बाय साइड काही करत नाहीये. तर ही स्किल्स असते ती मुलांना मग बाकीच्या मुंबई पुण्याकडे गेली तर मुलं काहीतरी हौशीने काहीतरी करत असतात आणि मग त्यांना ती भवितव्यात उपयोगी पडते. आपल्या इथं प्लेन एज्युकेशन असतंय तर ठीक आहे हे लायसन असेल, बट लायसन कॉपी इवन यू कॅन बाय सर. ही एक 10-20 पर्यंत येऊ शकते सर ही कॉपी. आणि यू कॅन गेट लायसन कॉपी सिंगल कॉपी फॉर डिपार्टमेंट. तर तुम्ही कायमस्वरूपी ती राहू शकते, त्याला काय हे नाही आहे. अपडेट्स पाहिजे असतील तर करू शकताय. तर याच दर्जाचे ओपन सोर्स पण आहेत, पण ते जरा युजर मॅन्युअल डाउनलोड करून शिकायला लागतात. बट यू कॅन गेट दिस काइंड ऑफ अ थिंग. म्हणजे तुम्हाला पायथॉन मधून सुद्धा असाच प्लॉट जनरेट करता येईल. यू कॅन डू दॅट. मॅटप्लॉटलिब म्हणून लायब्ररी आहे ती वापरून तुम्ही करू शकता. सो हे ऍड ऑन हँड जो आहे कम्प्युटेशन किंवा सॉफ्टवेअर लिटरसी किंवा लिनक्स वापरणं किंवा कम्प्युटेशन करणं हे ग्रॅज्युएशनच्या मुलांना करायला हरकत नाही आहे. इवन बायोलॉजीच्या मुलांना सुद्धा करायला हरकत नाही, म्हणजे लाईफ सायन्सेसच्या. कारण बायो पायथॉन पण आहे, म्हणजे जसं आपण इकडं आहे तसं बायोलॉजी मध्ये तुम्ही एक तसं हे वापरू शकता. सो देर आर सो मेनी सच थिंग्स. आणि फ्री आणि ओपन सोर्स सॉफ्टवेअर असतील तर काही इश्यूज नाही, नो इश्यू.
अच्छा.
So thanks for giving me an opportunity to talk with you and काही गोष्टी तुम्हाला मला दाखवता आल्या. या सरांबद्दल मी विद्यापीठाचे नावरे सरांचे माझ्या रिसर्च स्टुडंट तर पूर्णतः हेच वापरतात. माझी रिसर्च पब्लिकेशन आणि त्यात असणारे प्लॉट ह्याच्यामधूनच वापरतो. दीज आर पब्लिकेशन क्वालिटी प्लॉट असतात आणि हे 3D प्लॉट वगैरे आम्ही सगळे घालतो रिसर्च पेपर मध्ये आणि त्या दर्जाचे ते प्लॉट्स असू शकतात. म्हणजे त्याला काय हे नाहीये. दीज आर सम ब्युटिफुल प्लॉट्स विच यू कॅन जनरेट. कुणाला काही आहे विचारायचं तर सांगा. हे कसं आहे सर की मी तिथं असतो तर ती गोष्ट वेगळी, म्हणजे समोरासमोर असणं ही गोष्ट वेगळी असते. ऑनलाईन मुलं काही असतेत नसतेत. सो इज अगेन अन इश्यू इन पॅन्डेमिक सिच्युएशन. त्यामुळे सर काही असतील तर विचारा. आणि ते दोन्ही मॅडम तुमच्या आमच्या डिपार्टमेंटचे स्टुडंट आहेत.
होय होय.
त्यामुळे त्या दोघी येत असते तिथं.
होय होय होय. मध्ये 71 पार्टिसिपंट होते सर, म्हणजे आपलं हे व्हायच्या पूर्वी थोडा अर्ध्या तासापूर्वी.
Thank you, sir. Thank you very much for such a wonderful guidance about Mathematica, use of commands like solve, root, and more about transcendental functions, numerical computation, simulations, animations, and much more about plotting graphs, etc. Once again, thank you very much, sir. Uh, May I now request Dr. Tapase AB sir, in charge of Science Faculty, Balwan College, Vita, to enlighten us with delightful talk.
Good afternoon, all of you. Today, Department of Physics organized one-day online workshop on experimental physics under Lead College activity. Our college principal, Dr. Rajendra More Sahib, today's workshop resource person, Dr. Takali sir, Dr. N.L. Tarwal sir, Dr. N.S. Harali sir, Head of the Department, Professor Dr. Bobde sir, Coordinator of this workshop, Dr. Raut Madam, faculty members, different colleges students, and friends. The Lead College activity, it contains the first as the mission of the Lead College is as a homogeneous cluster of 10 to 15 college with an area fostering an inter-institutional cooperation for overall development of all of them is the basic principle behind the concept of Lead College. The concept is based on belief, effort of each and welfare of all is the concept of Lead College. The objective of the Lead College is the sharing of the information. Any information is shared about then sharing of the infrastructure facility, library facility, sports facility. These facilities also share the sharing of human resources. Then the collective organization of academic activity, different activities also organized with collaboration. Then helping faculty development, sharing of extension activities. These are the different objectives of the Lead College. Then in this experimental physics, the experimental physics चा उपयोग करून नवीन सॉफ्टवेअर कन्सेप्ट मॅथमॅटिकल ऍप्लिकेशन या आपल्या व्यवहारामध्ये कशा आणता येतील तर ह्या तंत्रज्ञानाचा उपयोग आपण इझिली केला पाहिजे तर हा मेन हेतू आहे. तसं पाहिलं तर भौतिकशास्त्र हे मानवी प्रगतीच्या गेल्या 2 शतकातील एक मोठं स्थान आहे. तर मूलभूत संकल्पनावर आधारित असणाऱ्या नवीन तंत्रज्ञान वाढवणाऱ्या भौतिकशास्त्राचे मोठे योगदान जगाला आज आहे. तर इलेक्ट्रोमॅग्नेटिक क्षेत्राच्या अभ्यासातून इलेक्ट्रिसिटी, कॉम्प्युटर्स, मोबाईल या तंत्रज्ञानाचा विकास झाला आणि आज त्याच्यामध्ये बरीच अशी क्रांती झाली. मोबाईलमुळे तर आपल्याला पाहतोय की जगामध्ये आजचं चित्र लगेच विदिन सेकंद आपल्याला आज पाहायला मिळतं. मध्ययुगाच्या काळामध्ये केपलर, गॅलिलिओ, न्यूटन यांनी प्रायोगिक व मोजणी पद्धत वापरून विविध जे नियम मांडले ते आज भौतिकशास्त्राचे मूलभूत नियम मानले जातात. तेच हा एक्सपेरिमेंटल फिजिक्सचा हा बेसच आहे. तर वेगवेगळे प्रयोग केले आणि त्याच्यामुळे आज नवीन संकल्पना आज उदयाला येत आहेत. आधुनिक भौतिकशास्त्राच्या 20व्या शतकात उदयाला आलेले अल्बर्ट आइन्स्टाईन यांनी तर क्वांटम मेकॅनिक्स या क्षेत्रात असाधारण कामगिरी केली आणि विश्व निर्मिती कशी झाली तर या प्रश्नाचे उत्तर मिळवण्यास या क्वांटम थेअरीमुळे आपल्याला मिळालं आणि हे सगळे हे एक्सपेरिमेंटल हे बरेच वर्ष केल्यानंतर आपल्याला त्याचं उत्तर मिळत आहे. आणि त्यांनी E=mc² हा सापेक्षता सिद्धांत मांडला आणि त्यात तो आजही आपण तो मानतोय. प्रसिद्ध भौतिकशास्त्रज्ञ न्यूटन असतील, आइन्स्टाईन असेल, मॅक्सवेल असेल, गॅलिलिओ असेल, तसेच औद्योगिक याच्यातले एम्पियर, लॉर्ड केल्विन, मॅक्स बॉर्न, व्होल्टाज, ओहम, फॅरेडेज, एडिसन यांच्या सिद्धांतामुळे तर विद्युत युग सुरू झालं आणि विद्युत युगामध्ये आज नवीन क्रांती होईल. नवीन तंत्रज्ञानाचा उपयोग आपण आज जगामध्ये करतोय. 20व्या शतकाच्या सुरुवातीला आइन्स्टाईनच्या शोधामुळे स्पेस, एनर्जी, मॅट, लाईट, ॲटम हे शब्द आज जगाला माहीत झाले. तर नाही आपल्याला आइन्स्टाईनची नसते तरी आपल्याला हे शब्द बघायला ऐकायलाही मिळाले नसते. जेम्स क्लर्क, मॅक्सवेल, हेनरी हर्ट्झ यांच्या इलेक्ट्रोमॅग्नेटिक लहरीचा उपयोग करून मार्कोनी यांनी रेडिओचा शोध लावला आणि रेडिओमध्ये क्रांती होत होत या इलेक्ट्रोमॅग्नेटिक वेव्हज चे एवढं प्रयोग आज तंत्रज्ञानाचा उपयोग करून नवीन नवीन फॅसिलिटी आपणाला आज गल्लीबोळापर्यंत पोहोचलेले आहेत. 1900 साली विल्यम रॉंगटेज आणि एक्स-रे किरणाचा ज्यावेळी शोध लावला आणि त्यामुळे त्याची मेडिकल फील्ड मध्ये आज रेडिओग्राफीच्या रूपानं रोगाच्या अंतरंग माहिती होऊन उपचार पद्धतीचा विकास झाला आणि उपचार पद्धतीमुळं आज माणसाचं आयुष्यमान सुद्धा ह्या तंत्रज्ञानामुळे वाढत चाललेलं आहे. तर थॉम्सनच्या इलेक्ट्रॉनच्या माध्यमातून मनोरंजनाचे नवे युग सुरू झाले. आज अखेर त्याच्यामध्ये क्रांती होत आहे. लॉर्ड रुदरफोर्डच्या अणुविभाजनामुळे एनरिको फर्मीच्या न्यूक्लिअर फिजन तत्वाचा जगात अणुऊर्जेपासून वीज निर्मिती पासून म्हणजे उपयोगी आणि दुरुपयोगी ॲटम बॉम्ब सारखे सुद्धा न्यूक्लिअर फिजनचा उपयोग करून आज जगाचं विध्वंसक सुद्धा आणि फायदा सुद्धा करण्याचं तत्व आज आपल्याला जगाला माहीत झाले आहे. अशा प्रकारे भौतिक शास्त्रातील शोधाने या जगाला मानवाला मानवोपयोगी वैज्ञानिक उपकरणाची निर्मिती करण्यात मदत केली आहे आणि या मानवी जीवन अधिक समृद्ध केले. या नव्या युगातील समस्या सोडण्याचे भौतिकशास्त्र भविष्यात प्रभावी भूमिका पार पाडणार आहे. यासाठी विद्यार्थी असतील, रिसर्च स्टुडंट असतील, रिसर्चर असतील, त्यांनी ह्या एक्सपेरिमेंटल फिजिक्सचा सखोल अभ्यास करून नवनवीन तंत्रज्ञान आत्मसात करावे, व नवयुगातील न्यूटन, गॅलिलो, मेरी क्युरी, आईन्स्टाईन सारखे शास्त्रज्ञ व्हावे हीच अपेक्षा व्यक्त करतो आणि थांबतो. धन्यवाद. जय कर्मवीर.
Thank you very much, sir, for your valuable insights. I am very happy to propose vote of thanks of this inaugural session. It is such an honor for me to get this opportunity. Honorable professors, respected teachers, students, on behalf of Department of Physics, Balwant College, Vita, I extend my sincere gratitude to our honorable chief guest, Dr. M.B. Thakre, sir, Department of Physics, Shivaji University, Kolhapur, to take out time from his busy encouraging us with your valuable talk. I would like to convey my sincere gratitude, Honorable Principal Dr. R.S. More, sir, and Dr. Tapase A.B. sirs, in charge of Science Faculty, Balwant College, Vita, as the president of this inaugural session. I am thankful to Dr. C.R. Bobre, sir, Head Department of Physics, Balwant College, Vita. I would like to express my heartfelt gratitude towards Dr. V.S. Raut, ma'am, coordinator of this workshop. I am thankful to respected teachers, my dear colleagues, students, and thank you one and all. Let us start the session of invited talks. I would like to request Mr. D.K. Dhongde, sir, Assistant Professor, Department of Physics, Balwant College, Vita, to give introduction of resource person, Dr. N.V. Tarwal, Assistant Professor, Department of Physics, Shivaji University, Kolhapur. Over to D.K. Dhongde, sir.
धोंगडे सर. मॅडम सर अजून जॉईन झाले नाहीत वाटतं. ठीक आहे.
Let us take a break for 20 minutes. We will join again for at 1:45 p.m.
Hello, madam. Hello. मॅडम आवाज येतोय?
हॅलो.
हा
हा सर, एक 10-15 मिनिटाचा ब्रेक घेतलाय.
चालेल.
आपण बरोबर 1:45 ला सुरू करतोय.
हो हो, ठीक आहे ठीक आहे. Dongre sir.
Let us
Tarwal
start
sir
the
is joined.
session of
Yes, sir.
invited talks. I would like to request Mr. D.K. Dhongre sir, Assistant Professor, Department of Physics, Balwant College, Vita, to give introduction of resource person, Dr. N. L. Tarwal sir, Assistant Professor, Department of Physics, Shivaji University, Kolhapur. Over to Mr. D.K. Dhongre sir.
Good afternoon, one and all. I once again welcome you all in one-day workshop on experimental physics under lead college activity organized by Department of Physics, Balwant College, Vita. Let me take an opportunity to introduce Honorable Dr. N. L. Tarwal sir. Sir received his PhD degree in physics in year 2011 from Shivaji University, Kolhapur, under the guidance of Honorable Professor Dr. P.S. Patil sir, Pro Vice Chancellor, Shivaji University, Kolhapur. After receiving PhD, sir has joined as an postdoctorate fellow for the period of year 2011 to 2014 at Research Institute of Solar and Sustainable Energy, Gwangju Institute of Science and Technology, GIST, South Korea. Sir is currently working as an assistant professor at Department of Physics, Shivaji University, Kolhapur. In year May 2015, Sir received Young Scientist Award at Second International Conference on Science and Technology, ICSTS 2015, held at Colombo, Sri Lanka. Sir is also recipient of Young Associate Fellow in year 2019 of Maharashtra Academy of Science. Sir has received the international recognition in the World Scientist and University ranking in the year of 2020 and 2021 survey made by AD Scientific Index Science Ranking. Sir has also received the international recognition in Top Scientist Database made by Elsewhere Sciwell. His research interest lies in the area of solar cell, material science, nanotechnology, thin film, gas sensor, electrochemistry. Sir has published more than 70 research papers in various reputed peer-reviewed international journals in research interest with H-index 28 and citation index 1896. Sir has completed the minor research project under the research initiation scheme funded by Shivaji University, Kolhapur. Sir has received 4 best and outstanding presentation award in various national international conference. With this brief introduction, I would like to welcome Honorable Dr. N. L. Tarwal sir and request him to share his expertise in the field of experimental physics.
Yeah, thank you, Dinesh Dongre sir. Am I audible, sir?
Yeah,
Yes, sir.
Yeah.
Dongre sir, make him co-host.
Yes, yes. Okay, 1 minute.
Madam, screen is visible?
Yes, yes, screen is visible, sir.
Yes, sir.
Okay. Yeah. Good afternoon, all of you. Respected Principal More sir, respected Head of the Department, Professor C.R. Bobde sir, coordinator of this one-day online workshop, Dr. Vanita Raut madam, and student friends. I take this opportunity to thank all of them for inviting me for this online workshop on the experimental physics, which is organized by the Department of Physics, Balwant College Vita, in collaboration with the IQAC cell under the lead college activity. Myself, Dr. Yanel Tarwar, I am assistant professor. I am assistant professor from Department of Physics, Shivaji University, Kolhapur. Today I am here to deliver a talk on the experimental physics. Yeah, this is my outline of my presentation, where I will discuss about some experiment. Firstly, I will take the experiment on the solar cell. Actually, there are the two solar cell experiment where I will explain one by one, solar cell 1 and solar cell 2. Now, the second is the linear variable differential transformer, that is a LVDT, and third one is the temperature transducer. And after that, I will tell something about the staircase ramp generator and Young's modulus of the steel. Finally, I will conclude my presentation by the series and parallel LCR circuit, which is known as the resonance circuit. Now, all of us know that solar cells are very important in our today's life. A solar cell can be deposited in the lab, okay, and the solar panels are mounted on our roof in order to extract the solar energy to form the electrical energy. Okay. Now the solar cell are the devices which convert the solar energy into the electrical energy. Actually, there are the two experiments. Experiment number 1, in which we will study the current voltage characteristics of the two crystalline silicon solar cell, which are connected in the series as well as the parallel combination. And now the second experiment is that the aim of the second experiment, which is to study the photovoltaic response of the given solar cell, and second aim is that to study the current voltage characteristics of the solar cell under the illumination. Now, this is the solar cell, some introduction about the solar cell. The solar cell, I already told the definition of the solar cell. The solar cell is a device that converts the light energy into the electrical energy. The solar cell is also called as a photovoltaic cell. Okay. Then what are the application of the solar cell? The solar cell solar cells are used to produce the electrical power in the remote areas. Okay, from the power where the power from the power station is unavailable. Now the solar cells are used in for the charging purposes, for charging the mobiles as well as charging the batteries of the satellite. Where satellite means the satellites are moving in the space. Okay, where the electricity is not possible there. That's why electricity is not available in the space. That's why in order to move or in order to run the satellite, we need some solar cell. Okay, and the solar cells are used for the charging the batteries, and that can be movement that can be useful for the movement of the satellite. Also, the solar cell are used in the radio telephone device services. It is also used in the calculator, watches, etc. Now the solar cells work on the three parts. One is the solar collector. Then the solar storage batteries there. Actually there is need of the battery for storing the electric energy, and finally the inverter is used for the storing the electric energy. Now this is the principle of the solar cell. The solar cell are based on the principle of the photovoltaic effect. Actually, there is some difference between the photovoltaic effect and the photoelectric effect. Actually, I will explain the difference between the photovoltaic and photoelectric effect in next slide. Actually, the photovoltaic effect, which is generally observed in the semiconductor, which is a photo generation of the charge carriers in the light absorbing material. Actually, light absorbing materials means the semiconductors only. Actually, there are the three kinds of the solids are there. One is the metal, another is the semiconductor, and third one is the insulator. And now while taking the example of the semiconductor, there is a generation of the photo generation of the charge carriers in presence of light. Okay, and as a result of the absorption of the light radiations. Now this is the construction of the solar cell. You can see the example. This is the construction of the solar cell here, right side. Actually, solar cell is nothing but it is just like a junction of the P and N type semiconductor layer. See, this is the example. This is the construction of the solar cell here. There is a P type junction, P type semiconductor, and there is the N type semiconductor, and this is a junction formed by the PN junction here. Okay, P type semiconductor and N type semiconductor. Actually, these two layers, that is a P and N type layers, semiconductor layers, are sandwiched in order to form the PN junction. Actually, the surface is coated with the actually this is the formation of PN junction, and when light is incident on the junction, there is formation of the EHPs. We can say that is the electron hole pair. Okay. Now this is the construction of the solar cell, and after constructing this PN junction, we need that anti-reflection coating. The surface is coated with the anti-reflection coating to avoid the loss of incident light energy to the reflection. And finally, we have to cover the glass here. Okay, and there are the two contacts here. One is the front contact and another is the back contact in order to catch the electron here from the PN junction. Now, this is the difference between the photovoltaic effect and photoelectric effect. Generally, the photovoltaic effect is observed in the semiconductor, while the photoelectric effect is observed in the metal here.
हॅलो तरवाळ सर.
सरांना कॉल करा की मॅडम.
हा सर, करते सर.
हा. काय झालं मॅडम? हॅलो. तुम्ही अनम्यूट करा बरं. काय झालं? अनम्यूट व्हा मॅडम.
सर 2 मिनिटात जॉईन होतील. आपण जरा
हो.
वाट बघूयात सर.
हो.
Hello, madam.
ओके सर, यू कंटिन्यू.
Yeah. Actually, the host is disabled. Actually, madam, please make me co-host.
येस. दोंगडे सर,
हा.
प्लीज मेक तरवाळ सर को होस्ट.
पोस्ट करा सरांना.
Now it's okay.
केले सर, पोस्ट केलं.
Yeah.
हा, 1 मिनिट सर. हा, येस. ओके सर.
Yeah. Okay, ma'am. Here. Hello.
येस सर.
Yeah. Am I audible?
येस, यू आर ऑडिबल सर. यू प्रोसीड.
Okay. Yeah. Okay. Yeah. Actually, I'm here. This is the difference between the photovoltaic effect as well as the photoelectric effect here. Okay. Actually, the photovoltaic effect, which is observed in the semiconductor, where the photovoltaic effect is observed in the metal only. See, this is the junction between the P-type semiconductor and N-type semiconductor. We can take the example of silicon here. N-type silicon and P-type silicon is there. And while making the junction, after sandwiching the N and P-type semiconductor, see, this is the junction formation. And this generation of the voltage across the PN junction in semiconductor due to the absorption of light radiation is called as the photovoltaic effect. And the devices based on this effect is nothing but the photovoltaic devices. While the photoelectric effect, which is observed in the metal, see, there is some threshold frequency of the metal. And the frequency of the incident radiation, which is a greater threshold frequency, then there is the electron is knocked out from the metal surfaces. See, this is the, and which is observed in the we can say tungsten, where tungsten is used in the our electric bulb. Okay, which is our home. There is another thing that the number of photoelectron generated, which is directly proportional to the intensity of the radiations, and the photoelectric emission starts as soon as the radiation falls on the metal surface. Now I will discuss about the semiconductor. The semiconductors having the band gap energy lies between the 1 to 3 electron volt. Such materials have the small conductivity that lies between the conductivity of the conductors as well as the conductivity of the insulator. the materials having the valence band and conduction band only. And the what is meant by valence band? Actually, the energy bands which is completely filled is nothing but the valence band, and the energy bands which is completely empty, it is called as the conduction band. And the difference between the valence band, that is the actually top of the valence band, and the bottom of the conduction band is nothing but the band gap. Okay, this is the picture of the difference between the metal and this metal, actually, that we can say that is the conductor, and then semiconductor, and that insulator. For the semiconductor, we have the band gap here, and the band gap between, this is the band gap, which is the gap between the valence band and conduction band in the semiconductor, which is in the around 1 to 3 electron volt. But while we taking the example of the conductor, we can say the different metal, there is the valence band and conduction band are just crossed here, and there is no band gap in the metal. While we are taking the insulator, for example, the rubber, wood. Okay, this is the kind, this is the types of the insulator, and see for the insulator there is a large difference between the valence band and the conduction band. Now, see, this is our just picture of the semiconductor, where there is some actually valence band which is filled by the number of electrons, and this is the conduction band which is empty of the empty band. And there is some actually there is some this one is the line, we can say it is a Fermi energy line, where this is the in middle position. Fermi line in the middle position for the intrinsic semiconductor, which is the upper for the n-type semiconductor, and which is the lower for the p-type semiconductor. Okay, now this is the p-n junction. Actually, how we can make the p-n junction? Okay, there is a simple way for making the p-n junction diodes. We are taking the silicon, for example, here silicon crystal. Now silicon is doped with some trivalent impurity like boron, aluminum, gallium, and indium. Okay, and another we can say another doping is there, that is a pentavalent impurity. Here pentavalence means actually there are the excess of the electron, and when we dope the trivalent impurity, there is some excess of the holes here. Now in order to make the doping, okay, the boron, aluminum, gallium, indium is doped into silicon, we can form the actually p-type semiconductor. And here when we dope the pentavalent impurity like in nitrogen, phosphorus, arsenic, antimony into the silicon, we can get the actually n-type semiconductor. And finally, while doping this silicon, two types of the silicon, one is the n-type and p-type, we just make the sandwich here, and after that we can get the p-n junction. Now the diode, we can say it is actually this is the p-n junction diode. This is a p-n junction diode. When actually we are connected in the forward bias here, then what happens? Actually, the number of holes are transferred to this way, actually crossing the junction, and goes to another direction, as well as the electrons from this n-type semiconductor there goes to this side. Okay, after crossing the junction. Now we can say, now we can see here there is a formation of the narrow depletion region for the forward bias here. While we can take actually when we take the condition of the reverse bias, now what happens here? The p-type semiconductor is connected to the n here, and n-type semiconductor is connected to the positive. Then what happens? There is a wide depletion. Actually, there is some increase in the depletion region. And now this we can say it is wide depletion region. Now what happens here when we have the narrow depletion region? There what happens? Actually, the electron from this side to this side goes on very fastly. But here, in case of the reverse bias, we cannot flow. Actually, we cannot get the flow of the electron from this side because there is some wide depletion region. Okay. Now this is the formula used for the calculation of the fill factor and efficiency of the solar cell. The fill factor formula is IMVM upon ISC VOC, and the efficiency is nothing but IMVM upon the P input. The IMVM means the maximum current and maximum voltage. We can calculate it by this ISC VOC into fill factor. Okay, the another formula for the getting the efficiency here, efficiency in the percentage, which can be calculated by ISC VOC into fill factor upon P input into 100. Now, what is meant by the short circuit current and what is meant by the open circuit voltage? The short circuit current is defined by the maximum current okay, from the solar cell when the voltage across the device is 0. And what is meant by the open circuit voltage? The open circuit voltage is defined as the maximum voltage from the solar cell when the current through the device is 0. We can say here 0. Now the fill factor is the ratio of maximum power to the this one is the, we can say it is a ISC VOC. Okay, and the efficiency is nothing but the it is a ratio of the power output to the input power. Okay, and this is the actual experiment of the solar cell. The aim of the experiment is nothing but the aim of the experiment is nothing but to study the current voltage characteristics of the two crystalline silicon solar cell connected in the series and parallel combination. See here, this is our solar simulator setup, which is in our lab here. We need apparatus like the solar simulator kit, then we need AC power supply, voltmeter, ammeter, and some jumping wires we need for the connections. Now this is the actual setup, and here we have this one is our two solar cells are here, one solar panels are here, and one other solar panel is here, and two solar cells are here are mounted in the actually solar simulator. And when we are connected in the series as well as the parallel combination, we just make the series and parallel combination as shown in the figure. Now what happens, actually this is the procedure. Actually we have some two potentiometer here. There are the two potentiometer. One is the potentiometer is nothing but the 0 to 10 ohm, and another potentiometer is the 0 to 100 ohm. Okay, actually 10 ohm pot is a single ton, and the 100 ohm pot is the 10 ton pot. Actually we have some 10 tons here. Now what happens here, actually for the first procedure, we can make the both the pots clockwise, means 100 ohm actually pot and 10 ohm pot becomes a clockwise. Means this is the condition for getting the voltage high and the current low, because when we increase this one, pot increases means the resistance increases and the resistance become maximum here, and therefore we get the current value is very low. Okay, now the second position is that just actually this one is to get clockwise and this one is also clockwise. Then what happens, actually the next procedure is that actually this 10 ton that one is the 0 to 100 ohm pot is here, and just we have to make slowly it anti-clockwise. Then what happens, and we just release this resistance, okay, this maximum to minimum, then we will get some reading of the I and V. And finally, if it close to 10 ton here, then we just move this one, slowly make the anti-clockwise of the 10 ohm here. Likewise, we have to take the readings of the I and V. Okay, this is observation table for the series combination and as well as the parallel combination. We have to take the reading like while decreasing the resistance. Okay, we can say decreasing the pot here. Now we can get the value of the just like observation table 1 to 10 here. Now we can get the value of for the series combination, we can get the value of like highest voltage. We can say that is open circuit voltage here. And for the current value, we can see this is the short circuit current, which is observed for the last reading of the current here. Now this in order to make the calculation of the power here, then we have to multiply this I into V here. Then we can get the power which is in the watt. Okay. Now similarly, the procedure will follow for the parallel combination. Now the VOC value is high for the first reading of the voltage, while for the last reading of the current, we can get the highest value of the current. We can say it is the ISC value, and after multiplying this value, we can say we can get the power value. Now we have to plot the current versus here. This one is the y-axis, actually current value here, and this is the voltage here. Then we have to plot this like this one. Then if you plot the voltage versus current here, or current versus voltage, we can get this plot like this one. This is a knee like a plot. Okay. Now we have to make the power maximum in order to just making this one tangential from this point to this one and this one to this one. Then after getting the here intersection, then we just this point connected to the here origin value, and then after that we can get the some P max value here. This is the value of the P max, and while considering the P max here, then just draw the tangent here like this one and this one here. Okay, then we can get here VOC value, and here we can get the Actually, see, this is not VOC. This is a VM. Actually, sorry, this is a VM in maximum current, and this one is the IM, maximum current. Okay, and maximum voltage here. Now, actually, this one is the VOC value, and this one is the ISC value. See, this one is the ISC, means short circuit current. The short circuit current means nothing but the current is which is the high one at the low value of the voltage, and the VOC is nothing but the highest voltage at the time the current is at 0. Okay. Now we have the two solar cells, and while calculating the P input by calculation of the by formula here, intensity of the light and area of the solar cell into number of solar cell, then we can get the P input. Otherwise, another way is that to measuring the P input, just we have to make the we have to take the lux meter, and we just place the lux meter in front of the lamp. Then we can get directly value of the P input. Another way is to find the P input. Okay, now this is the formula for the fill factor, and this is the formula for the efficiency. Actually, what happens actually generally for solar cell, ideal solar cell, we get the IV characteristic like the rectangular, like this one. Okay, but there is some difference between but there is some loss of the power. That's why the actually the IV characteristics goes on just decreasing here, or it shows like knee-like structure. Okay, now this is our result of the experiment, where we can find the efficiency of the solar cell in the combination, which is in the percentage here, as well as the for second combination we can calculate the efficiency by formula, which is in the percentage here. Now the second experiment is here of the solar cell is shown here. Now the aim of the experiment to study the photo response of the given solar cell. Now the IV characteristics, study the IV characteristics of the solar cell under the illumination. Now here apparatus is just like we need some solar cell, then IV measurement kit, then 100 watt tungsten lamp, we need some scale. Okay, this is procedure, or this is a diagram for the first part 1 and part 2 here. Actually, see there is some lamp, and this one is the solar cell is here, and then there is a combination of the voltmeter, current, and resistance here. Now there is another term is the, another scale. We can say there is scale for the scale is used in order to make some distance from the solar. Actually, this one is the lamp and the solar cell. Okay, this is the picture for the part 1, and this is picture for the part 2 here. We have to in part 2 we have to study the photo response characteristics of the given solar cell. Okay, here actually we can say here only the voltage and current meter is used in order to measure the IV characteristic of the solar cell. Okay, now this is the part 1. In part 1 we have to place the distance between the solar lamp here, lamp between the lamp and the actually solar cell, which is defined by the scale here. Now we can take the distance as a 12 centimeter, 18 centimeter, or 25. You can take your choice. This distance up your choice. We generally take the ring like 10, 15, 20 like this one. And now if you take the reading like D is equal distance between the lamp and the solar cell is like 12 centimeter, then we have some resistance value here. Okay, now in order to vary the resistance value, that is the load of the resistance load RL, then it goes on increasing here. See the current increasing, while the current increasing we can get the current value, while the resistance value is increasing we can get the current value decreasing here. Okay, highest resistance we can get the lowest current. Okay, and that time there is a actually value of the voltage here. Okay, gets increasing here. Now similarly in the last experiment we have to just make the multiplication of the current and voltage in order to find the power. Okay, into I into V. Okay, here now in the second part actually we have to change some distance. Okay, we have to take the distance from 10 to 50 centimeter, and in order to that we have to make some intensity of the, we have to check the intensity of the lamp, okay, while changing the distance from 10 to 50, and then we have to measure some current as well as the voltage value, and finally there is some line of there is one column we can take the ln of the FL here, the intensity of the ln of the intensity here. Now we have to plot the graph like this one. Okay. Now first graph is just I versus V. Okay, the I versus V means we get the knee-like curve here. We can, from which we can find the ISC, VOC, IM, VM, Pmax value, and after that we can get the efficiency of the solar cell. Okay, here what happens actually, this is a example of the first experiment. We can say that is the first distance, that is a d is equal to 12 centimeter. See, as the distance increases, what happens? The intensity of the lamp, okay, goes on decreasing. That's why actually current and voltage becomes decreases here. Means that's why the intensity increasing, the distance increases. We can get the efficiency of the solar cell goes on decreasing here. Okay, and see, this is the voltage across voltage versus the intensity plot. We can see here on y-axis we can plot the VOC, and here intensity of the lamp. Then we can get the slowly goes on just increasing the intensity here. Just VOC just goes on just increasing, but it's stable here. Okay, see, means that as the intensity increasing, it also increases, but after some time it is saturated here. Okay, now third one is the graph. Just it is the plot of the ISC versus intensity. Just like here we can say the intensity of the lamp just goes on increasing. Intensity means just we have to, distance is same, and but intensity of the lamp is glowing, means glowing, intensity of lamp is increasing. Then what happens? The current is current in the solar cell just dramatically increasing. Okay, this is the example of the ISC and intensity. Okay, this is when we plot the ISC versus intensity, then we can get the straight line is directly proportional. Okay, now this is the result of the experiment. We have to take the different reading like 12 centimeter, 15 centimeter, like this one, and then we have to find the formula, fill factor formula, and then finally efficiency we can calculate in a percentage. Now the result of the part 2 is nothing but we have to find out the ideality factor. Okay, now the ideality factor we have to calculate from the actually plot of the graph, actually graph of the ln IFL versus the VOC, and then we have to take the slope from that graph, and we have to plot, we have to put the slope here in order to find the ideality factor E into slope upon KT. Okay, then for this experiment we have calculated the ideality factor like 0.2 into 10⁻⁻3, and the conclusion of this experiment, as the distance between the solar cell and the sources increases, the efficiency of the solar cell increasing here. And now this one is the it is also required to low input power for the large distance between the source and solar cell. Now this is experiment number 3, where I discuss about the LVDT. LVDT is the passive transducer as well as the linear displacement transducer. A transducer is a device which converts one form energy into the another form. And what are the application of the transducer? It produces the high resolution. It produces the high sensitivity. It is a small in size and weightless. Okay, this is the LVDT. How LVDT works? Okay, LVDT is the electromagnetic induction. Actually, we know the Faraday's law of the electromagnetic induction, where E is directly proportional to the E d phi by dt. Whenever there is a change in the magnetic flux associated with the coil and the EMF induced in the neighboring coil, the magnitude of the EMF produced EMF directly proportional to the rate of change of magnetic flux. Okay, but according to the Lenz's law, it is a negative because it is opposite direction. That's why it E is equal to minus d phi by dt. We can write. And this is the construction of LVDT, where we have some core inside the actually inside this here formula. Actually, the core is a magnetic material. That's why when it moves from left to right here, this direction, there is actually there is some depletion in the EMF here. Okay, when it is placed in the middle one, then there is, see, this one is the middle one. Then what happen? Actually, there is a, we can get the null deflection. While it moves like left side, then actually secondary one. Actually here the output of the secondary one is highest one. That's why we can get the E out is equal to E1 minus E. When the former is actually the core just displaced from right side here, from center to right side, then we can get the E2 minus E1. The difference between the EMF is nothing but the E2 minus E1, and for the left side it is the E1 minus E2. For the center position, it gets some zero deflection. Okay, this is the construction of the LVDT, and this is the actually core is nothing but the magnetic, which is made up of the magnetic material. That's why there is we can observe the EMF. So this is actually experiment where the aim of the experiment is to study the LVDT transducer, measures the electromagnetic force EMF in terms of the displacement of the ferromagnetic core of the transducer. We need some apparatus like LVDT, then DPM here. Then there is an observation table. One to just we can take the observation. Like we have to just change the displacement. Okay, in terms of the mm, and then we just find the DPM reading. DPM reading means it is a just differential output voltage. Okay, voltage that is the EMF change in the EMF we can find here. And when we actually displace this rod from the plus 50 to minus 50, we can get DPM right like a similar way. Like for 50 millimeter, we can get the 70.6 millivolt. For the minus 50, we can get similar like this one, minus 70.4. Okay, this is the plot of the graph here. When we plot the DPM versus the actually mm, that is a displacement, then we can find here the difference output voltage versus the displacement. Then we can get the straight line from the which goes through the origin O. Okay, this is for the actually straight line. Okay, now this is the result. Output voltage is directly proportional to the core displacement. When we increase the core here from left to right, then the voltage also increasing here. Okay, the LVDT transducer measure the EMF in terms of the displacement of the ferromagnetic core, and the conclusion of this experiment, the mechanical energy can be converted into the electrical energy by using the LVDT transducer. Okay, now this is the experiment number 4, where I will tell about the more information about the temperature transducer here. Now the temperature transducer is nothing but is a device which converts the signal from one form of energy into the signal from the another form, or otherwise another definition is that the transducer is a device which transforms the non-electrical physical quantity, which is temperature here, which converted into the electric signal. Now types of the temperature transducer 3 here. That is thermocouple, then semiconductor sensor, and thermistor here. Now thermocouple we have used in this experiment. The thermocouple means what actually there are the two dissimilar metals that are the connected. We can say here we can solve that two dissimilar metals here, and then there is formation of the thermocouple. Now thermocouple is the electric device which consists of the two dissimilar metal forming the single soldered junction here, which shows the different temperature like T1, T2. Now thermocouple are operates on the principle of the Seebeck effect. Now the Seebeck effect is stated that when the two different metals are joined together at the junction, there is formation of EMF. Okay. Now this is the semiconductor sensor. See, this one is the picture of the semiconductor junction sensor. The semiconductor sensor can be used for measuring the temperature in the environmental range of the 55 to 50 degrees Celsius. And this is the special type of the semiconductor sensor, that is the AD590, is a two-terminal integrated circuit temperature transducer which produces the output current proportional to the absolute temperature. Now third one is the just thermistor. Thermistor is another specific type of the resistor. There is a thermistor devices which whose resistance changes with the temperature. Hence, it needs the electrical supply to give the whole output. There are two types of thermistor, which one is the NTC and there is a PTC. NTC means that the negative temperature coefficient, it has some negative temperature coefficient, and the positive, another PTC has the positive temperature coefficient. This is the actual setup or actual experiment. Yeah, the aim of the experiment to study the characteristic of the variety of the temperature transducer and also verify the performance of the instrumentation amplifier used. Actually, this is the apparatus which are needed for this experiment: temperature transducer circuit, differential, where we can use some thermocouple, semiconductor sensor, thermistor, oven, etc. This is the formula for this calculation. CMMR, common mode rejection ratio, which is equal to 20 log of AV upon AC, where AV is the differential voltage gain and common mode gain. Yeah, this is a kit front panel display here, where we can have some oven here. We have to put the thermocouple, thermopile here, and another terminal we have to put like this one. There are the 6 holes are here, 1, 2, 3, 4, and 6, 5, 6. We have to place here. When we connect the thermocouple, then we have to put here. We have to join this these two terminals here. And when we are taking the example of the semiconductor here, then we can put this one. And finally, we can take the another example of thermistor here. Then we have to use these 2 pins. Okay. Now this is there is some observation table. We have to and 50, and we can observe the input voltage here for calculating the differential gain and common mode gain. E1, E2, and E0. There is another. We have to just make the by using the multimeter, we can get the input voltage. Finally, we can calculate the CMR. Yeah, actually observation table for this 3 types of the transducer. Now, madam, am I audible?
Yes, you are audible, but
PPT presentation is visible or not?
No, sir.
just now. You share screen once again, sir.
Now, okay, madam?
Yeah. Yes.
Yes, sir. Yes, sir.
Yeah, this is observation table. For the first, we have to use the thermocouple here, and we have to just raise the temperature from room temperature to 70 degrees Celsius. Then we have to make some amplifier output here. Okay, we have to measure the amplifier output. Finally, just like thermocouple, we have to use the semiconductor sensor and the thermistor here, and then we have to make the reading of the amplifier output. Now, in order to plot the amplifier output versus the temperature for the thermocouple and IC sensor, we can get like this one. Okay, the graph like this one over here, and for the amplifier for the actually thermistor, we can get the graph like this one. Okay, this is the sum. We can say it is a positive slope, and this is a negative slope. Okay. Now the result of this experiment, the amplifier output of the thermocouple and semiconductor sensor increases with the increase in the temperature, and the amplifier output of the thermistor decreases with the increase in the temperature. Now, what is the conclusion of this experiment? The temperature coefficient is positive for the thermocouple and IC sensor. So the graph is linear, but the slope is positive. And the second one, the temperature coefficient is negative for the thermistor. So the graph is linear, but the slope is negative. Now, this is the experiment number 5, where I will tell about this, something about the staircase ramp generator. Here, what is meant by ramp generator? Ramp generator is the function generator that increases the output voltage to up to the specific value, which is called as a ramp. Now the staircase ramp generator, it is the apparatus which receives the sequence of the input pulses and generates the staircase waveform that is it increases the amplitude of the input signal stepwise with the input clock pulse. Now, this is the theory of the UJT, unijunction transistor, which is used for the solid state triggering devices. It is made up of the N-type and P-type material. It has the 3 terminals. We can say it is the emitter, base 1 and base 2. See, this one is the construction of the UJT, where we can find some 2 bases are base 1 and base 2, and this is the emitter here. It is also called as a double base diode because of the 2 bases. This device has unique characteristics when triggered. emitter current voltage increases. Emitter current increases until it is limited by the emitter power supply. It also exhibits negative resistance characteristics, which makes useful as an oscillator. The UJT consists of the light doped N-type silicon bar. Actually, this one is a silicon bar, and heavily P-type. This one P-type, heavily P-type actually a region grown inside on the into the bar. The terminal which is connected to the P-type silicon is called as the emitter, as well as the two terminals are nothing but the base B1 and B2. Here, and this is the IV characteristic of the UJT, where we can get some three parts here. One is the cutoff region, and another is the negative resistance region. Third one is the saturation region. And what are the application of here? Yes, UJT we can use to vary the voltages in the step function. Sampling for scope uses a step generator to trace out the family of the BJT, FPT, IV characteristics on the CRO. We have to trace out. We have to trace out the difference between these two. Okay. Now this is actually experiment where the aim of this experiment is to study the staircase ramp generator. We need some apparatus like frequency generator, CRO, power supply, and components. We need some UJT, then diode, then some capacitors, 0.1. Okay. Now this is circuit diagram where this one is our frequency generator, where this one is the capacitance C1 and capacitance C2 is here connected here. Actually, this one is a 0.01 microfarad, and this one is a 0.1 microfarad. This is a 10 times larger than this capacitance here, and diode D1 and D2, which is used for the actually controlling the current in one direction only here. See, this one is our UJT. UJT number 2N2646 is here. Actually, plus VCC voltage is applied here. And now what happened actually for positive pulse, actually D1, D2. Actually, the diode D1 is just in forward bias. Therefore, the current flows from this direction, and with this current, actually, this capacitor goes on charging here. That capacitance charging, actually, this one is gets charged. Capacitance C1 gets charged, and after that, it discharges from diode D2, and in order to charge the capacitance C2. Similarly, there is some 10 transition happening here, because capacitance C1 and C2. In order to make the comparison, C1 is very small and this one is large one. And then in order to charge the capacitance C2, we need some like this function. We have to just goes on charging capacitance, then discharging this one, discharging this one, then discharging. This process is going on. And after getting the full charge of the capacitance C2, it just goes decrease, means we can say it is a discharge through the UJT. Now there is formation of like this observed output on the CRO. We can get some output like this one, charging, get, and after that the UJT starts conducting, we can say here, then it like discharge. We can get the discharge line. Now there are the two parts, where first part we can say here, this is check the weather connection as per this given circuit. Then the frequency, we have to give some frequency constant, 1 kilohertz or 2 kilohertz, we have to put the constant, then adjust the value of the VOC, okay, VCC, then to get the staircase ramp on the CRO. Finally, number of steps we have to measure, and the steps of the step amplitude with respect to VCC. And this is the actually experimental setup, where we have some CRO, then we have some power supply, and then frequency generator, and this is our circuit. Now this is the part 2, where we can place some constant VCC voltage, that is a 2 volt or 3 volt. Now we have to vary the frequency in order to change some frequency from 1 kilohertz to 10 kilohertz. Then we have to make the step amplitude here, and finally plot the graph of the step amplitude as a frequency here. Now this is the observation table, where in part one we can get the we have to put some constant frequency like 1 kilohertz, and just take the reading like the number of steps. There are the number of steps observed in the CRO. The first step we can get some value, then we can calculate the step amplitude here like this one. Okay. Now for the second one, we have to put the constant value VCC, that is a 4 volt, and just we have to change the frequency like 1 kilohertz, then 2 kilohertz, 3 kilohertz, 4 kilohertz, 5 kilohertz, like this. But there is, we can say, in order to change the while changing the frequency, there is the step amplitude cannot be changed, means it's stable here. That's the 2 voltage. Now these are some plots when we plot the part one, we plot the number of step versus the voltage, we can get the state like this one, increasing plot here. And but for the part two, step amplitude versus the frequency, we can get the stable plot here because the VCC value is stable here. Now the result of this experiment is at constant frequency, the number of steps are increased with respect to the VCC. And the second part, that the constant value VCC, the step amplitude remains constant, we can say remains constant here with increasing the frequency. Now this is the conclusion where conclude at the constant frequency, number of steps can be increased by increasing the VCC. And the part two, that constant VCC step amplitude is independent of the frequency, means it cannot be changed. Okay, finally it is possible to construct the electronic circuit which gives the step amp voltage in a ramp. And the experiment number 6, which is related to the Young's modulus of the steel. Okay, this is the we have the knowledge of enough knowledge of the elasticity, like the rubber elasticity mean it is the property by virtue the which material's bodies regain its original dimension, size, shape, and both after removal of the deforming force is nothing but the elasticity, and the deformation is nothing but the change in the size, shape, and both of the body arising due to the external force called as the deformation. The deformation may be into the which can be happen or which can be seen into the by changing the length, by changing the volume, or changing the shape. Now this is the strain and stress. We already know about this one, stress and strain. The different types of the stresses are here, and different types of the strains are there. Finally, we know the Hooke's law, strain is directly proportional to the strain. Then we have to just stress upon strain. Then we can get the E is the modulus of elasticity. And formula one is nothing but the Young's modulus, where we can find the formula for the Young's modulus, that is the ratio of the tensile stress upon tensile strain. Okay, now this is actually experiment where the aim of the experiment is to find out, to verify that the fundamental frequency of the vibration of the steel bar clamped at the one end here, which is inversely proportional to the square of its length, and to measure the Young's modulus here. Now this is our steel. Actually, the steel bar is having the 30 centimeter length here. We need this apparatus like the rectangular steel bar like this one, and then we need some signal generator, and we need some power amplifier. This is the formula for calculating Y. Y is equal to 4 pi square rho 12 upon 1.8, that is a D, we can say, into D square into FL square in bracket square, where rho is the density of the steel here, D is the thickness of the steel bar, length of the DL is the length of the steel bar, frequency of the vibration, and Young's modulus. Actually, this is the procedure for doing the experiment. Here we have to just firstly we have to just clamp the bar at a distance 20 centimeter. Okay, now this is our experimental setup here. This one is a bar. We have to place the bar at the 20 centimeter, and the distance between the magnet and this bar is just we have to place 1 centimeter. Now what happens, just we have to increase the frequency like the 30 hertz here. Then we just goes on increasing here frequency. Then there is formation of the vibrations. Okay, and then we can get some vibration. Then that vibration we can say that frequency is 14.4 hertz. Okay, at this frequency the rod is just vibrating. Okay, the rod having the length of 20 centimeter, then it's vibrating. Now similarly, if we reduce the steel bar length by 2 centimeter, then what happens, the frequency of the vibration this goes on increasing here. Now just we have to just make a simple calculation, 1 upon F, then L square, we have to this one, then L square in centimeter square, then meter square. Then we have to make the this combination, means multiplication of the F L square here. Okay, and actually for this observation we have two observation thickness. We have to find out the thickness. Okay, this is the by using the micrometer screw gauge we have to find this thickness, as well as we know some density of the steel bar like 7850 kilogram meters. Okay, and now this is the nature of the graph of this experiment, where we can get the some increasing trend here. Now when we plot the L square versus 1 upon S, then what happened, there is we can get some graph like the straight line here. Okay, now the result we can calculated by using this Young's modulus experiment. That is the Young's modulus of the steel bar is nothing but we have calculated like 1.6 into 10 raised to 11 Newton meter square. Okay, now and the final conclusion of this experiment, the fundamental frequency of the vibration of the steel bar clamped at the one end is inversely proportional to the square of its length. Okay, now this is experiment number 7. Experiment number 7, which consists of the series and parallel LCR circuit, where this is the resonance in the series and parallel circuits we can study here. Now this is some resistance and just like L and C, R, L, C, we can say they are connected in the series here, the LRC. Okay, that is the inductor, we can say inductor, and then capacitor and resistance, they are connected in the parallel. And what happens actually when they are connected in the series here, that circuit is known as the acceptor circuit, which means that it allows the maximum current to flow through it. Okay, but here this is a rejector circuit, means what happened actually, it allows the minimum current. Okay, or we can say it is the rejector circuit. Okay, now these are some application of the resonance circuit here, which can be used in the radio, TV, oscillators, musical instruments, and filters. The aim of the experiment is to study the impedance of the LCR circuit and in impedance of the LCR circuit, which is connected into series as well as the parallel. And note that here the impedance of the LCR circuit is a minimum, and the impedance of this parallel LCR circuit is maximum. Okay, at the resonant frequency. Actually, for both the circuit, the resonant frequency is similar one. Having the formula f0 is equal to 1/2 pi under root of LC. Therefore, the resonance frequency of the series LCR circuit is equal to the resonance frequency of the parallel LCR circuit. Now, these are some components that can be used as in the experiment: resistance 1 kilo ohm, inductors 100 millihenry, and capacitor 0.033 microfarad. This is some connection of the LCR series, and this is the connection of the parallel LCR circuit. Now, see, this one is some in order to check the voltage between the resistance. Therefore, this is the VR, and voltage between the L means the inductance, we can say that is the VL. Now the voltage between these two terminals, that is the VC. Okay, now similarly we can find some voltage, total voltage is like V, and VZ we have to find some VZ voltage, means VZ means it is just the voltage between the L and C, this one. Okay, similarly the resistance value is here VR, VL. Okay, and VZ is like this one. Okay, this is in the parallel circuit. This is actually set up for the LCR circuit, where we have to just make the here connection, like we have to put like resistance here, then inductance here, then here capacitors here. We have to put this series circuit, and then we need some measure the voltage from this resistance here, two terminals of the resistor, two terminals of the inductance, and two terminals of the capacitor by using the multimeter. Okay, now signal generator is used here. Okay, and we have to just make the observation table like for the series LCR circuit, like when we change the frequency here from 1 to something here, okay, kilohertz, then we can find some difference here, voltage of the resistor, then voltage between the conductance, inductance and capacitor. We have to write this one. Okay, now finally there is one column where there is a ratio of VZ and VR. Yeah, this one we can plot here. Okay, now observation for the LCR parallel LCR circuit, like similar to the series circuit, same. We have to plot like VR, VZ, and VZ by VR. Okay, now what happened actually when we plot the VZ by VR? Actually, this one is actually there is some ratio here, VZ by VR. Then it looks like just goes on decreasing to the frequency. This is the resonating frequency. Then this difference decreasing up to the resonating frequency, and after resonating frequency it goes on increasing here for the LCR circuit, means series resonance circuit. For parallel resonance circuit, the similar, the VZ by VR. Hello. Hello, sir.
Okay, sir. It's okay.
Similarly, the VZ by VR ratio goes on increasing up to the resonant frequency up to this one, and after resonant frequency it goes on decreasing like this one. Okay, this happened for the parallel resonance circuit. And the resonant circuit, the result of this experiment to find out the impedance of the LCR series LCR circuit, that is a very minimum, you can say it is a 2.4 at the resonant frequency, and the impedance of the parallel LCR circuit is around, means it is a maximum. Now the conclusion of the experiment is the impedance is minimum for the LCR series LCR, and the impedance of the parallel is maximum for the parallel LCR. Yeah, thank you, sir.
Thank you. Okay. Madam. Shinde ma'am.
Thank you very much, sir, to give the
Yeah, thank you, ma'am.
information, for giving the information about practicals with the help of NIND's presentations. Thank you very much.
Yeah, thank you, ma'am.
Okay, and now we are moving toward the session second. May I now request Ms. S.M. Rautale, ma'am,
No, no,
Assistant
no, no.
Professor, Department of Physics,
No, no.
Balwant
Madam.
College, Vita.
सरांचं vote of thanks propose करा ना.
Hello? Hello, sir?
रावताळे मॅडम vote of thanks propose करणार आहेत ना.
नाही
Okay. Thank you, sir. Thank you very much. Okay.
Hello, may I know, sir? May I leave now, sir?
Hello.
May I leave now, sir?
Okay, sir. There is any
Okay, thank you,
question?
sir. Yeah.
Okay.
Thank you, sir.
Okay. Thank you very much for nice talk, sir.
Yeah, thank you, sir. Thank you for giving me opportunity. Yeah, awesome. Bye.
Okay. Thanks. Okay.
Good afternoon, one and all. I once again welcome you all in one-day workshop on experimental physics under Lead College activity organized by Department of Physics, Balwant College, Vita. Let me take an opportunity to introduce Dr. N.S. Harale, sir. Sir received his PhD degree in physics in July 2017 from Shivaji University, Kolhapur, under the guidance of Honorable Professor Dr. P.S. Patil, Pro Vice Chancellor, Shivaji University, Kolhapur. Sir is working as an assistant professor at Department of Physics, Ray Shikshan Sanstha, GM College, Karad. Sir has recipient of JRF by DRDO, New Delhi. Also, he was recipient of Best Image Award Material Today Cover Competition 2013. He was program committee member of various international and national conference workshop. Sir has also received 3 Best Poster Presentation Award, also 2 Best Oral Presentation Awards. Sir has received 9 prizes in Avishkar Research Competition. He has 10-year teaching and research experience. Sir has published 38 international research papers with H-index 15 and citation index 808. His 2 patents in process. Sir has presented 44 papers in international and national conferences. His research interest in gas sensor, energy harvesting, nanomaterials, quantum dots, solar cell, supercapacitor, and smart window coating. With this brief introduction, I would like to welcome Dr. N.S. Harale, sir, and request him to share his expertise in the field of experimental physics.
Okay, thank you. Thank you very much, ma'am, for your nice introduction. Okay, I'm sharing my screen. Okay, my screen is visible, ma'am.
Yes, sir.
Yes, sir.
It's okay.
Okay, thank you very much. This Department of Physics organized one-day online workshop on experimental physics, Balwant College, Vita. I'm very much thankful, respected More sir, principal, Professor C.R. Bobde sir, Head Department of Physics, Dr. Vanita Raut ma'am, coordinator, and other faculty members for inviting me to give some ideas, some information regarding experimental physics. So I am here to give you some explanation about practicals. So I'm starting my presentation. I'm Dr. Namdev Rade, working as assistant professor in Department of Physics, Sadhguru Gadge Maharaj College, Karad. So this is picture, front view of my college. Beautiful campus there. I think few faculty members, they are already familiar with this campus. Then this one is a central library, and this one is a boys hostel. So just small introduction about my college. Now we all are giving some idea about this student, all faculty members, and giving some idea. There is always a source of inspiration. So students and all other, suppose small boys are there. They are thinking that, these are the Spider-Man, Iron Man. These like superheroes. They have extra power. Why this power comes? This power comes to the new advanced technologies. Okay, so these are the only imaginary, but by using the science, we can create such type of things in our life. So see, the few examples are there, like invention of nanocar, then this technology, like latest technology, which is nanotechnology. Before this technology, we have to go for fundamental science. Then fundamental science, we have to convert into technology, and then this technology, when you make the advancement in the technology, then this one is a new technology or modern technology. So such type of present nanotechnology is a new technology where you can use anywhere. So before going to that new technology, okay, so this modern technology where you can use to control the pollution, to for biological applications, for medical field, okay, in case of farming, agriculture field, or to make the energy harvesting devices or energy conversion devices. So these are the new technologies. We are already familiar with these new technologies. But before that, we have to must understood the basic idea behind this technology. So we have to go for science. Science is the first term, and then this science one can convert into the application part, which is related to technology. So science is a methodological, we can say, way of gaining the knowledge on a particular subject, any subject, through a observations and experiments, doing some experiments, and by using that, doing some experiments, if you take the results, and by using that results, you can apply this knowledge to the society, then you can say this one is a technological invention. So we are physics students. So where physics one can use in modern technology, one can use the physics. Alternative energy source, I have shown the diagram of nuclear reactor where you can use this physics. In robotics, in artificial intelligence, in molecular and cellular processing, in engineering, everywhere one can use this subject physics. So physics is specialized in different branches like solid state physics, material science, then space science, optics, energy science, theoretical physics. Okay, these are some few branches of physics. These are the specialization. But there is another important specialization, or you can say fundamental things, experimental physics. We are studying the laws, various laws here in laboratory, or in theory part, we are studying the different laws. But in practical, we are verifying these laws, okay, verifying these different concepts there. So this experimental physics is very important. We have to study this experimental physics. Now, if you compare the physics versus engineering, engineering is application, you can say, a part. So physics one can use in the development and in variety of applications like space. I've already given you this example. Then automobile sector, then electronic sector, technological, then aerospace, where you can use this physics, okay? Because this physics is a fundamental subject. Now, if we are dealing with some experimental, if I have shown two images there, you can see there are different machineries are there. So these are all related to experimental physics. You can perform experiments on that, some laser experiment doing there. One scientist is doing some optics experiment. See, the variety of instruments are there. So we must be familiar with the instruments and instrumentation tools. Now, see, another one example I'm giving here, the breakthrough in quantum physics. So see, the reaction of quantum fluid to photoexcitation of a dissolved particle observed for the first time. So why they are succeeded to do this such type of invention? Because to the expertise in experimental physics. So we all must be expertise in theory as well as experimental physics. So starting with the basic concept, what is physics? Physics is the most basic of all the sciences. Sometimes it is called as parent of all sciences. What phenomena, what part involved in physics? So it's the study of behavior and the structure of matter and energy and the interaction between that, both between that matter and energy, which involves in the physics. If you take the examples here, there must be a communication required between that architecture and engineer. Like in physics, we are dealing with this wave. So there is always interference, maybe sometimes constructive, maybe sometimes destructive. So if the constructive interference there, see the picture I have shown here, see the bridge, and another one image showing the collapse or disaster occurs there. So that's why we have to know the physics, know the fundamental laws, and we have to verify that laws. So physics as an experimental science. That's why this workshop given the theme like experimental physics. So experiments and observations are involved in the physics. So these are the two important steps, okay, to form a scientific theory. So theories, what is the meaning of theory? Theories can one can create theories to explain the experimental and observations. And before that, we have to make some experiments. Before predicting or before proposing any theory, we have to make some we have to do some experiments, and we have to make some observation, and from that observations one can make some conclusions and one can propose the theory. We are already familiar with this fundamental tools, okay, up to BSc part. Okay, I think few BSc students are there. So these are the few fundamental tools one can use for the experimental physics, like Vernier caliper, micrometer, screw gauge, a spectrometer. These are some of these fundamental tools. There are so many small equipment, small tools are there to start the fundamental experimental physics, okay, part. And students, they are doing some experiments laboratory by using small kits are there. So for focusing the MSc part for students or postgraduate student or PhD students, we have to discuss about the some few experiments which involves in the experimental physics. So I'm starting here with the first experiment, which is a Hall effect. So am I audible clearly? Hello, am I audible?
Yes, sir.
Okay. So can I continue?
Yes, sir.
Yes, sir.
Okay. So we are discussing the first experiment, which is a Hall effect. So see, this one is a picture showing the experimental arrangement for to study the Hall effect. So Hall effect, this experiment consists the following components, you can say. First one is a Hall probe. Then next one is a Hall effect total setup. We require electromagnet, then constant current, power supply, digital Gauss meter, and computer interface, if you are interested to know the graphs directly on the computer. So before starting the experimental part, we have to just know what is the meaning of that Hall effect, what is the concept of Hall effect. So see, when a current carrying a conductor is placed in a magnetic field, a potential difference is generated in the direction which is perpendicular to both the current as well as magnetic field. So see the image, see the current carrying conductor is there, and electric current shown by this red color, and magnetic field shown by the green line. So when this conductor which is carrying the current, and if you place in the magnetic field, then there is a potential difference generated in the direction which is perpendicularly to both in case of current as well as magnetic field. So this phenomena is known as a Hall effect. So it rises from the deflection of charges, because see in conductor also there are the positive charge, and another one is electrons carrying negative charge. So one can observe this effect as well as in metals as well as in case of semiconductors. Okay, so in practical purpose, we are studying the semiconductors for practical purpose. Again, why we are interested to do these experiments? Okay, so from this experiment, we can calculate the Hall coefficient, which is given by RH, and density of charge carriers, which is represented by small n. What is the formula for that? RH is equal to Z into VH divided by I into B. What is Z given there? Thickness of the crystal. What is VH? VH represent the Hall effect of Hall voltage. Then I represent the probe current, and B, which is the applied magnetic field. What is E? Is an electronic charge. And from that, another one formula one can calculate. So another one formula is there, N is equal to 1 upon RH into E. By using that two formulas, one can calculate this coefficient as well as carrier concentration. So we can observe this Hall effect in N-type semiconductor as well as P-type semiconductor. What is happening here? So see, if the magnetic field is applied for the N-type semiconductor, we have that N-type semiconductor. What is happening when you place in the magnetic field? So both the free electrons and as well as holes are pushed down towards the bottom surface of the N-type semiconductor, and the holes are negligible in N-type semiconductor because these majority charge carriers are electrons in N-type semiconductor. So what is happening there? So the free electrons are mostly accumulated at the bottom surface of the N-type semiconductor. So what is happening there? The shifting of charges occurs. So similarly, in case of Hall effect, in case of P-type semiconductor, oppositely occurs in the same case. So we have already seen the picture experimental setup. So here is the panel diagram of Hall effect experiment. So we require the electromagnet, then Gauss meter, then constant current power supply, and the front panel display shown in this diagram. So what are the apparatus? Hall probe we required, then Hall effect setup we required, then again electromagnet, constant current power supply, and digital Gauss meter. These are the important components we require to study the Hall effect. So this one is a brochure. I'm not going to the details. After doing this experiment, so first we require to calibrate this Gauss meter. How one can calibrate? You can use the current. See the observation table in first part, current in case of ampere, or you can say in milliampere range, and magnetic field in kilo Gauss. So see these are the values for the current and respective magnetic field, and from by using that graph, okay, graph of current versus magnetic field, if you plot that graph, you will get this such type of calibration curve. So on y-axis magnetic field is there, and on x-axis current is there. So it may be in milliampere range. So second part, we have to study the Hall effect in first second part, which is the keeping the probe current constant and varying the magnetic field. So what is the value for that? Probe current is a 3.5 milliampere current, and a sample which is germanium crystal, which is N-type. So see the observation table here. We have to take this reading for current, then magnetic field, and then generated Hall voltage. So by using this, one can plot this another one graph, which is a Hall voltage versus magnetic field. So on y-axis Hall voltage there, and on x-axis magnetic field is there. And the graph, see the graph, nature of graph is a straight line. If you take this slope, then you will get the value. Then what type of calculation we have to do there? So see experimental data, probe current we have kept as a 3.5 milliampere. Then slope of graph we have calculated from this graph, how much the slope. Then one can calculate the Hall coefficient by using this formula and calculations. Another one part is there. So keeping probe current constant and varying the magnetic field. So probe current, how much probe current is 8 milliampere, and then we are varying the magnetic field. Then again you will get this such type of observations. Then you have to again do the calculations by using that graph. See another one graph is there, Hall voltage versus probe current is graph, and by using that slope of that graph, you can calculate the Hall coefficient given with this formula. Then we can and what is the result for that? So by using that calculations, one can find out the value for what is the Hall coefficient value. as we have mentioned there, first part, one can calculate the carrier concentrations also. See there, by using this formula, one can easily calculate the carrier concentration for this N-type semiconductor or some P-type semiconductor. You can calculate, depends on the which semiconductor you are using for this experimental part. Second experiment is related to crystal structure. We are already familiar with that. Say in crystal, okay. So we have that two types of materials, like one can say a crystalline material, in that polycrystalline, single crystalline, or another one amorphous. So we know that in case of amorphous, there is no any particular arrangement or periodic arrangement, but in crystalline material, there is a particular arrangement is there. So see there, this one is representing the small unit cell, and by using with the help of this unit cell, see this is a crystal lattice, so formation of lattice takes place. And there are different types of crystal systems. I can say tetragonal, then orthorhombic, monoclinic. There are a variety. There are 14 sub-crystal systems are there, and some examples where crystals where this type of system observe monoclinic, triclinic, hexagonal, trigonal. There are some different crystal structure systems I have shown here. So see, simple, then face-centered, the body-centered. These are the cubic systems, then monoclinic, orthorhombic, and these are the basic structures. Okay, how this arrangement takes place, that is, or you can say atomic arrangement present in such type of systems. Then we have to identify. In suppose I have crystal, unknown crystal, and I want to classify that crystal into the variety of systems are there, maybe cubic system or monoclinic. So how I can understand, how I can know which crystal system is present in that crystal? So for that, one technique is there. There are many techniques, but out of that, one technique I am discussing here to know the crystal structure, which is the famous technique, X-ray diffraction technique. So again, there are powder X-ray diffraction also present. So this one is a schematic representation for this X-ray diffraction technique. So here we are using the X-ray as a source for that, and this X-ray we are bombarding on that crystal, and we are getting the diffraction pattern. Okay, so see, this one is a schematic representation for this X-ray diffraction technique. So there are two types of, one is sometimes sample is rotating, otherwise the source is rotating. This type of arrangement is there, and you are getting the diffraction pattern. So what is the base for that? Why we are getting the diffraction pattern? So fundamental things in this, which is the this X-ray diffraction technique, which is based on the Bragg's law. What is the formula for that? Constructive interference. We are getting the constructive interference when this condition gets satisfied. N lambda is equal to 2d sin theta. We are already familiar with that. And this figure shows the a photograph of X-ray diffraction XRD system. Then what type of data we are getting from this after this using this X-ray diffraction technique? So see, this type of pattern we are getting, and this pattern is known as X-ray diffraction pattern. So intensity versus 2 theta, and here we are indexing that planes. Okay, 100, 002, like that. On how we are indexing this by using this JCPDS card, which is ICDT data matching. One can get this idea, and one can identify whether which system, which crystal structure system is present in our sample. Suppose I have Jadeno sample, then if I record this X-ray diffraction pattern of this zinc oxide, then we will match this with JCPDS cards, and then we'll find out the hexagonal crystal section present in this X-ray diffraction by using this X-ray diffraction pattern in case of Jadeno sample. So for practical purpose, we have to do some calculations and find out the different values. So first part is related to determine the crystal structure and this find out these values, d values, and crystal. You can calculate the values like crystallite size also by using this X-ray diffraction pattern. So what apparatus required? Only we require this X-ray diffraction patterns, and there are formula 1 upon d square is equal to s square divided by s square plus k square divided by b square and plus L square divided by c square. What is ABC? ABCD, that is constant, you can say, that is parameter. And by using that Bragg's law, 2d sin theta is equal to n lambda, one can calculate the d. What is the d? D is the spacing between that two atomic planes. You can see d is equal to n lambda divided by 2 sin theta. And lambda, we are already familiar with that. Lambda is equal to 1.54 angstrom. This is the wavelength of that X-ray used for this X-ray diffraction technique. What is the observation table? Here we have to take this 2 theta from this X-ray diffraction pattern. So see this X-ray diffraction pattern, and from this X-ray diffraction pattern, we have to calculate the 2 theta values. Then divided by 2, you will get the theta. Then take the sign for that. Then take the sin theta, and then calculate the d value, d interlength. This spacing we can say. And here is a plane, d standards. D standards means by using that JSPDS card pattern, you will get the value, and here you can calculate this value. So these are the calculation I am showing you because a student get idea how to do the calculations. Okay, so to calculate the d here and to calculate the lattice parameter, these are two calculations, and then take the average for that, and you will get this. Take the average for that, you will get this value in terms of angstrom. Then crystal, see this lattice, you can say lattice parameter, which are the ABC parameters, and these are the calculated, and these are the standard values we received from this JSPDS cards. Okay, and by using that relation, so I have shown that 7 fundamental crystal structures or systems, you can say. Here A is equal to B but not equal to C. From that relation, one can identify whether which type of system is there. So tetragonal, trigonal, or monoclinic. So different, or cubic, one can get the idea from using this calculations. Okay. A similar way, there is another one technique to know the crystal structure, which is a neutron diffraction. So see, similar way to this X-ray diffraction technique, there is the neutron diffraction technique. So neutron diffraction is the application of neutron scattering. See, in X-ray diffraction, the diffraction phenomena take place. So similar way here also, this application of neutron scattering to this determination of the atomic, or you can say magnetic structure of a material. In case you can also examine that the other properties also by using that texture coefficient and other parts one can calculate also. So similar way you can compare this X-ray diffraction technique and neutron diffraction technique. You will find that very similar, both techniques are very similar. So this one is a schematic representation for that. And this X-ray diffraction pattern, we are also getting the neutron diffraction pattern. So again, same intensity versus 2D plot is there, and see, similar way you are getting these patterns, peaks present in that neutron diffraction pattern. By using that peaks, you can make the calculations, and to one can find out this lattice constants also. So what is the aim for that? So aim is to determine the lattice constant from given neutron diffraction pattern, and to find out the crystal structure of a given any Farad samples or any other samples. So what apparatus you require? You require only neutron diffraction pattern as like a X-ray diffraction pattern in case of earlier experiment, and formula which is a similar way. 2d sin theta is equal to n lambda, and also DHKL you can calculate A divided by under root of h square plus k square plus L square. What is A is the lattice constant, HKL Miller indices, and D represent the interplanar spacing. So what is the observation table for that? Similarly in earlier experiment, the observation table is same. Here we have to take the HKL planes observed from this or obtained from this neutron diffraction pattern, and then 2 theta, similar way you have to find out the 2 theta divided by 2, you will get the theta, then sin theta. Then by using that Bragg's law, okay, 2d sin theta is equal to n lambda. Similar way here, d is equal to lambda divided by 2 sin theta, and from that you can calculate the parameters also, and d value also. So these are the calculations. Okay, each planes you can calculate the value for d, small d, spacing you can calculate, and keep in mind this distance d value for d is in terms of always in angstrom. So one can find out also these lattice constants by using that neutron diffraction pattern similar to the earlier experiment. Next experiment is related to find out this Planck's constant. Before this starting the experiment, we have to know the idea about this Planck's constant experiments. Okay, so starting with the Planck's law, if you study the black body radiations, we are already familiar with that black body radiation. So in that, this classical physics, or one can say statistical electrodynamics, which cannot explain the experimentally observed spectra of radiation. So Max Planck's given the idea about that, and here H represents the Planck's constant. So this constants comes, okay, suppose the E energy E is equal to h mu, we already familiar with this equation. Again, E is equal to h mu is equal to sc upon. So given by this Planck's Einstein relation, and we have to find out this H value for H, which is the Planck's constant, by using some experiment. We have to verify this value. That's why we have to do some experiments. This one, this part is related to theory part, related to this Planck's constant. E represent the energy, H represent the Planck's constant from this above equation. Mu represent the frequency, C is the speed of light, and lambda is a wavelength. Okay, so already we know this value, but experimentally we have to verify this value. So what is the aim for this experiment? Aim to determine the value of Planck's constant by using this photocell. Here we are using the photocell. This one is a schematic representation, a diagram, you can say circuit diagram. This is source, we have to connect here voltmeter to know the voltage, and here another one current meter is there, and we have to use different filters there, and by using this formula one can calculate this value. There are different types of filters are there, so red filter, green filter, blue filter, and one can calculate the values. And we have to take the mean for that. So H1 plus H2 plus H3 divided by 3, you can calculate the Planck's constant mean value by using this. So first part, then second part, different wavelengths are given here, lambda 1, lambda 2, lambda 3, and by using this formula, one can calculate the value for that. So what is the observation table? What type of observation we have to take for this? We have to note down for this experiment. So see there, filter first, which is a red, then another one filter, second filter. So we have to take the only readings for this voltage and current. Similar way, we have to take the reading for filter third one, which is a blue, then voltage and current you have to note down. And this type of calculation, see, formula is given here, and we have to do the calculations, and we have to make the average for that. You will get the value for Planck's constant, simple way. Then next experiment is related to know the to calculate the Stephan constants. So before starting the experiment, we have to know about this. What is Stephan's law, sometimes known as Stephan's law of radiations. So what this law state? This law stated that the rate of change in the radiation energy of a body, which is proportional to the difference of the fourth power of the absolute temperature, m, which is represented by m of a surrounding medium, and fourth power of the absolute temperature T of that body. So given this law represented in this symbolically, dt by small dt, okay, small t is there, is equal to k into m raised to 4 minus t raised to 4. Is one graph by through equation one can represent this Stephan's law. Again, if you take this fundamental part of this Stephan's law, okay, already familiar with this equations. For hot objects, we can consider any hot body. For other than ideal radiators, the law express this Stephan's law one can express in terms of P divided by A is equal to E into sigma into T raised to 4. But we have to calculate this Stephan constant. Okay, according to this Stephan's law, E energy, which is directly proportional to the fourth power of this temperature, or E is equal to sigma into T raised to 4. So what is a sigma? Sigma is the proportionality constant and called as a Stephan constant. We already know this value. Sometimes this this Stephen's constant is always sometimes known as Stephen-Boseman constant also. So what type of experiment we have to do, and how we are verifying this value for Stephen constant? So what is the aim for this experiment? Aim to determine the Stephen constants of a radiation. What apparatus we required? A constant current source we required, then DC differential amplifier setup we required for the measuring the Stephen constants. The kit is provided, so Bestow like company or SAES company provide this kit, a ready kit for this. But what is the fundamental part? What is the inside of that? So see, the diagrammatically I have shown here schematic representation for the experimental arrangement, and second part is related to setup for the measuring the Stephen constant. So see, the actual setup here, Stephen to measure the or to calculate the Stephen constant. So sigma one can calculate it by this given equation, P into I divided by A into T raised to 4 minus T0 raised to 4, and the parts parameters given here, sigma represent the Stephen constant, then voltage, current, at what is T0, and A area of that copper plate given here. What is observations here? We have to take the observation, time in second, then temperature in degrees Celsius, and temperature we have to make in Kelvin. Then again another observation table is there, voltage in volt, then current in ampere, or you can take in milliampere, then temperature, then again you have to make the temperature. So here is correction we record a temperature in Kelvin. Okay, last part steady state is a temperature T0 in Kelvin. Then by using this formula, by using this calculation, doing the calculation, one can calculate the value for sigma, and sigma is nothing but Stephen constant. Another experiment we have to perform in particularly MSc part first, related to know the resistivity of this any material, resistivity of semiconductor or okay, N-type semiconductor or P-type semiconductor one can measure, or thin films one can measure by using these different techniques are there. So before starting the experimental part, we have to know these fundamental things related to this resistivity experiment. So the basic part or fundamental part is behind this resistivity experiment is Ohm's law. We are already familiar with this. P is equal to IR. Okay, if you plot this current versus voltage characteristics, you can see this straight line nature. When you are getting this such type of nature, when your resistance of that circuit, or not circuit, you can consider the resistance of your sample is a constant, then in that case you are getting the straight line behavior, and that device you can say ohmic devices. Non-ohmic devices where the resistance is not constant and you are not getting the straight line curve, current versus voltage, you are getting some different behavior. So in that case you can say like non-ohmic devices. Then electrical resistivity. Okay, so see, if you have any conductor like semiconductor or a conductor, V potential, I current flowing through that, and R, what is R? Is a resistance, means opposition to this flow of charges or flow of current. If you have that any bar or semiconductor, or you can consider a metal having the length L, and then A is a cross-sectional area for that, rho represent the resistivity. So resistance per unit area, just simple a resistivity. Resistance represent symbolic notation given here, R representation of this resistance. So R sometimes known as okay, so resistivity or R is equal to rho into 1 divided by you can just put the value per unit area. If you consider, then you will get the value for that resistivity. So there are different techniques or method for this measurement of this resistivity of any sample. Okay, consider semiconductor thin film. Direct method, then two probe method, then Van der Pol method, and four probe method. These are the four fundamental techniques you can say to know the resistivity of particularly for this MSc part. We have to use the thin films, and then we have to calculate the resistivity measurement. So you can use a direct method. What is the direct method? Suppose you have that sample like low conductive low resistive sample like FTO sample, a fluorine doped tin oxide sample, like conductive, you can say conductive sample. Then by using some simple multimeter, you can know the resistance, and knowing the area, you can easily calculate the resistivity. This one is the direct method, 2-probe method and 4-probe method, and another one 1-probe method is there. So these are some different methods where you have to do some experimental work, and then you can calculate the resistivity value for that. So we are discussing first part is a 2-probe resistivity. This, sorry, rather than 2-probe, just consider here 4-probe. So this one is the experimental setup for the 4-probe. See, oven is there, and the sample we have kept inside of that oven, and we are heating that sample, and we are measuring the value for that current voltage. So what is the aim for that? So aim is to determine the resistivity of semiconductor at different temperature and to obtain the band gap, but not we are calculating band gap here, we are calculating activation energy there. So this one is an experimental representation. So there are 4 probe number 1, 2, 3, 4, and in between that probe number 2 and 3, we are measuring the voltage in between that. So there is a small difference in between that 2-probe resistivity measurement and 4-probe resistivity measurement system. As name stated, in case of 4-probe, we are using the 4-probe, and in case of 2-probe, we are using only 2-probe. But the value, the more accurate if you take, then this 4-probe method is more accurate, but it is useful for this low resistive materials only. So what is the value given? If you purchase the kit, then this value will be provided through this company, distance between that probe, then thickness, then constant value. Okay, these are all provided along with this kit also. Then formula given here, then by using that formula you can calculate, and activation energy also you can calculate by using that doing some calculation and knowing the slope. Okay, so constant current we have already taken here, value 5 milliampere, and at that value we have to take the reading, temperature, then temperature in degrees Celsius, then voltage, then resistance. Okay, then you have to calculate the resistivity by using that by knowing the putting the area, then 1000 divided by T, and then log rho. So if you plot that, you will get the graph, and by using that graph you will get the value for this here. And if you put that value of that slope, then you can calculate, rather than, keep in mind there is a typing mistake, rather than Ag you have to you can calculate the EA. EA is the activation energy, and activation energy of given semiconductor we can calculate by using this simple experimentation. So this one is a procedure for that, and see, this one is a graph. Okay, nature of that graph, and by using that, see the nature of the graph, and by using that slope, value of slope, you can calculate the activation energy. You have to put the value for slope here, and then you can easily calculate. Then another one, okay, this one is a fundamental part or theory behind this experimental 4-probe setup here. So in current, so see, voltage we are measuring in between that probe number 3 and probe number 2, and these probes we are mounting on that wafer, maybe germanium wafer or silicon wafer, and we are measuring the resistivity of that semiconductor. Similar way, there is another one method to know the resistivity of that sample, which is a 2-probe resistivity measurement of thin films. We can measure the resistivity by using this particular 2-probe method. So this, see this image, this left side image represent the resistivity kit, ready kit, and this inner view or probe view of this resistivity unit shown on right hand side. So what is the aim? Just a simple to determine the resistivity of a given film. Here we are not using any wafer, we are using here a thin film deposited in your laboratory. You can use this thin film for the measurement of resistivity or to know the resistivity of that thin film. So what apparatus we record? We record the 2-probe kit, then multimeter we record, voltmeter, one you can use for as a current meter, another one voltmeter, connecting wires, etc. Then diagram, just simple construction. or schematic representation there. A thin film you have to mount below that probe carefully, and then you have to connect the here DC power supply, and you have to supply some voltage like 2 volt or 5 volt, and you have to measure the current. So what is our observation table? Observation table, see, in that you have to mention their voltage, how much voltage you have applied. So for example, 12.91 voltage is there, applied voltage. Then temperature, because we have to take the reading with respect to temperature. First, we have to heat that sample up to 250 degrees Celsius, up to 250 degrees Celsius, and then we have to take the reading, natural cooling reading. Then that temperature we have to convert into K. Why? Because we have to plot that graph. Okay, so 1000 divided by T temperature, you have to take the reading, and then by using just simple Ohm's law, you can calculate the R value for R, and by using that value of R, you can calculate the rho resistivity value, and then you have to take the log rho value. And by using that graph similar way as we have seen in 4 probe, you can plot that graph and you can calculate the activation energy. So what is the result? The result is the resistivity of given material, which is it is not a result. We have to put the value for that, and you can say conclusion, resistivity of given material, which is decreases with the temperature. So if your sample is suppose your sample is a metal, suppose 3 type of sample. One is a metal, then semiconductor, and then insulator. So in case of metal, what is happening in case of resistivity and conductivity? In case of metal, the resistivity increases with respect to temperature, right? Because the collision increases with increasing the temperature, and that's why the resistance or resistivity value increases, and there is a decrease in the conductivity in case of metal. Opposite phenomena is one can observe in case of semiconductor. So in with respect to temperature, there is increase in the temperature, so always there is a decrease in the resistivity and increase in the conductivity in case of semiconductors. These are the opposite behaviors. Next experiment or next experimental part is related to thermoelectric effect. So suppose we have the 2 type dissimilar wires. We have metal wires. Consider metal wire A and metal wire B. And if you make the junctions, so there are 2 junctions, junction number 1 and junction number 2. So if you put that junction number 1 at a hot end, you can consider at higher temperature, and another one junction number 2 as a low temperature, you can say cold region or cold junction for that, then you will observe there is a generation of potential difference due to this temperature gradient. Okay, so this type of, there are 3 types of different phenomena are there. Seebeck effect, Peltier effect, and Thomson effect. These are the 3 phenomena based on this involved in this thermoelectric effect. So due to this temperature difference, due to this temperature gradient, we are observing the voltage generation take place. So such type of this thermoelectric effect or thermocouples is the example. You can use this as a temperature sensor to know the temperature. One can use the thermocouple, and thermocouple is based on this thermoelectric effect. What type of experimental measurements were required to calculate the thermoelectric coefficient or to know the thermoelectric power? So see, this one is actual photograph of TEP setup, and another one right hand side image represent the inner view of this TEP unit. There are 2 probe films. Okay, 2 regions are there. One is a hot region and another one is a cold region. We have to put the eyes on a cold region, and heating coil is there inside that brass. Okay, so one can heat using this coil is there, and when you pass the current, so this region will get heated. So there is a temperature gradient generated here, and due to this temperature gradient, you are getting this voltage generation take place. So what type of experiment we have to carry out to know this TEP or thermoelectric power? So TEP measurement of this thin films, this one is the title of experiment, and what is the aim? To determine the thermoelectric power of a given material. What type of apparatus we required for that? We require the thermoelectric power kit, then thermostat, then digital panometer, or you can use as a normal multimeter to know this temperature or to know this thermoelectric power. So this shows this schematic representation, instrumental setup for this thermoelectric power measurement. Then what type of observation table we require? Observations, then temperature difference we have to measure, we have to convert it into Kelvin, and how much voltage we are observing there, we have to note down this. And formula is given here, thermoelectric power is equal to d by dt. What is d? Change in EMF voltage. What is dt? Change in temperature. And what is p? P represent the thermoelectric power. So procedure is given there, and by using this observation table, you can just calculate the thermo EMF of a given material, how much in terms of millivolt. What is the conclusion there from this experiment? As temperature, if the temperature is increases, then you will get the more and more thermoelectric power, or thermo EMF is also increases. Then nature of graph. What type of nature of graph you are observing in case of this TEP experiment? So on y-axis there is a thermo EMF in millivolt, and on x-axis there is a temperature in Kelvin. You will get the straight line curve, and slope you will get the value for d by dt. Then we have to shift, we have to move from this fundamental part to the actual applied part or application part. So we have to extend our this experimental physics to this research area. I'm giving you just idea about some field where one can use this experimental physics, and you can perform some experiments, and you can carry out your experiments, and you can do the research work in your particular area, like photo electrochemical solar cells, then supercapacitor and batteries, then electrochromism, gas sensor. These are the research areas, but also in this research areas also there is involved experimental physics, but some higher level experimental physics. So student up to BSc level or MSc first year, they may not be aware about this extended research area. I'm just giving you idea for that. Photoelectrochemical solar cell, which is known as a PEC solar cell. So this is not actual MSc part, first experimental. I'm giving you extra experimental related part. So in that photoelectrochemical, just we already you know about this solar cell. So similar here, small difference in normal PN junction solar cell and PEC solar cell, photoelectrochemical solar cell, because here we are using the electrolyte and two electrodes. One is a counter electrode, another one is a photoelectrode, and these two electrodes are immersed in the electrolyte. And when you insert the photon solar radiations on that photoelectrode, you will get this generation of voltage. So this type of new concept is there, which is known as a photoelectrochemical solar cell. Another one area, you can say thrust area, supercapacitor or batteries. These are the new technological area. So we are generating the energies, and we have to store that energy. And for storing the energy, we require the storage devices. Conventionally, we can store the energy in case of batteries or capacitors, but another one new branch is there, or new devices is there, which is a combination of capacitors and batteries. So you can say is a middle part on the Ragon plot. If you check, so the supercapacitor belongs to the middle part of this capacitor, and batteries I'm not going to details, but just see what experimental part, advanced part people are doing in this area. So display devices, and then foldable devices, then flexible batteries. We have to do a lot of things in this part. So these are some latest technology where you can use the supercapacitor or flexible battery devices in such type. Another one area, which is the electrochemical area, where also you have to do some experimental physics involved in that. So what experimental physics involved in that? If you coated some materials on window, and if you apply some potential, then this coating changes its color. This phenomenon is known as a electrochromic. Why electrochromic? Because we are applying some voltage and changing this color. Why this change in color observed in such type of devices? Because this optical transition take place in that. So see, this one is a schematic representation of metal oxide based electrochromic devices. See, then another one field is there. So gas sensor. So gas sensor, in that suppose there is a leakage of toxic gases, then maybe in the industrial area, maybe in laboratory, then we have to we must have this sensitive devices known as gas sensors, which detect that leakage, and this will give you a signal, okay, which can be easily observed or easily read by the observer or any instrument like alarm. So we'll get this idea about this gas leakage. Then different type of nanostructures is again this part is not related to your actual experimental physics, but this is an extended part of your experimental physics. Such type of nanostructures one can develop in laboratory, and you can use this such type of nanostructures for the fabrication of devices, which is involved in incorporated in modern technology or nanotechnology. So chemistry gas sensor based on this variety of nanostructures like nanobricks, nanoplates, porous structure, fern-like structure, all are such type of flower-like structure or plates. Okay, a cubes structure, microbricks, you can say. And in my PhD works, I have developed such type of devices, okay, sensor devices, and wireless security alert system I have developed. So these are the extended experimental part, okay, experimental physics part. Security system, security alert system I have developed during my PhD works, and these are few news. Last part related to research laboratory. While doing some experimental physics, we must require sophisticated laboratory equipments were required, and in Department of Physics, SGM College Karat, we have developed such type of laboratory for MSc Part First and MSc Part Second student. These are some experimental devices or instruments were installed in our laboratory to carry out some research work or experimental part. These are related to synthesis, hydrothermal, tip coating, sealer, spin coating. These are the advanced equipments are there. And we have that special equipments like electrospinning unit and sphere paralysis unit installed in our newly established physics research laboratory, where all faculty members and students must not be limited only up to this okay, laboratory level. We have to go to the extended area like research, and we have to carry out research project, research work at BSc level as well as MSc level. So for motivational, I'm showing you what type of facilities we have here in our college. Then these are some advanced instruments like TZDTA, then potenstat, UV visible, spectrophotometer. Newly we have purchased this PL instrument, then AS instrument. These are the newly purchased advanced instruments. Okay, then again this one representing this best image awards, materials today core competitions, this a few awards. This one is my profile on Scopus. This one is my research scholar profile. Okay, thank you very much. Thank you all.
Hello.
Hello.
Thank you, Dr. Yanis Harare, sir. Thank you for a very nice presentation.
Okay, thank you, sir.
If participant students, if they have any difficulty, they can ask to Harare, sir.
Yes, sir.
Yes.
Hello, sir.
Oh.
Yes.
From crystal structure practical,
Okay.
from exact data, how we calculate the HKL value?
Okay, suppose for experimental part, we are getting this data XRD pattern from X-ray diffraction. Okay, we know that we are getting that pattern, X-ray diffraction pattern, and there are different planes are there, and we have to match that data with JCPDS cards. Okay, that there are standard cards are there, and we have to match our X-ray raw data with that JCPDS card, and then we will get this peaks like 110, 220 or 002 like peaks, and you will be provided that peaks, okay, or HKL values from that X-ray diffraction patterns, and by using that X-ray diffraction patterns HKL values, you can calculate the D values or lattice parameters. So this value will be HKL value will be provided to you for doing this practical.
Okay, that value will be given.
Yes, yes, HKL value will be given to you, and from by using that HKL planes values, you have to do the calculation part, remaining part.
And sir, how to calculate the beta, half width of full maximum?
Okay, full width half maxima. So by using that Scherrer's equation or Scherrer formula, 0.9 lambda divided by beta cos theta, you have to find out the peak with maximum intensity. You can do this in origin also, but I'm giving you just a rough method. We have to find out this most intense peak. Then you have to calculate the full width half maxima from that peak. You will get the value. So theta 2 minus theta 1, and you will get the value for that beta.
Sir, please show you will give example by pattern, XRD pattern.
Okay, just 1 minute. I will share you my screen. Okay, I think screen is visible to all of you.
Yes, yes.
Okay, see there, there are many peaks. Okay, I mean just considering this most intense peak. Okay, this 101. Here, by taking this image, it is not possible. You have to go in origin software. Okay, raw data is there, and by using that raw data, you can plot that graph in X-ray so in origin software, and from that origin software, you can easily calculate the full width half maxima. Suppose this one is the most intense peak, then you, okay, just 1 minute. So see, this one is the most intense peak, and then from that origin, you have to take this half of that, and then you have to make the perpendicular lines on that graph, and here you will get this theta 2, and this one is a theta 1, and take the difference in between that, you will get the value for beta. But this one is a rough method. By using this only image, it is not possible to calculate the value. You have to go in origin software, and there you will get the accurate value for that beta. So 0.9 lambda divided by beta cos theta, you can easily calculate the D. D is a, you can see crystallite size. Is it clear to you?
Yes, sir. But how we can calculate the theta from the given XRD pattern? In
Theta. Theta.
Theta.
Okay, okay. Yes, yes. So the XRD pattern will be provided starting with this 0, suppose, or you can take this one scale bar, and there is one line intercept method is there. I have not shown in my presentation. By using that line intercept method, first you have to measure this length. Okay, suppose this theta from 25 to the 30, then you have to calculate the for 1 centimeter how much theta, or one or single theta is equal to how much the length, and by using that value you can easily calculate the value for theta. It is not a theta, it will give only 2 theta, then divide by 2, you will get the theta. There is one another method which is known as a line intercept method, and by using that line intercept method, you will identify or easily calculate the value for theta. Suppose here 45 and here is a 50, then you have to make first the measure this length, and by using this length, you can make how much 1 centimeter is equal to how much theta, or inversely you can how much theta is equal to, okay, just for single theta, how much the length, okay, value in terms of centimeter, point something, and then you can take this point here, you will get the value for that 2 theta, and divided by 2, you will get the value for theta. So there is one method which is the line intercept method. You have to measure this by length with scale, and then you have to calculate.
Okay,
is it clear?
You, yes, sir. Thank you.
So this experimental part, see, I'm showing you on the screen by virtually So student must do this experiment. Better way offline mode is very important for that. Just showing this experimental part, it is very difficult to understood this concept and how to do this experiment. It is very easy to me to show just a slide, but it is very difficult to participant or student how to perform that experiment, how to take this reading, how to do the calculation. That's why I have shown you directly these calculations. Okay, because sometimes students, they are making complaint like, sir, result we are not getting accurate result, like that. So that's why I have shown you this experimental and calculation part also on the screen. Okay.
Okay. Thank you very much, sir, for such a nice presentation of practicals like Hall effect, crystal structure, neutron diffraction, Planck's constant, measurement of resistivity, thermoelectric effect, and extended research areas like PEC, solar cells, supercapacitors, etc. Once again, thank you very much, sir. Now, we are moving toward the valedictory section of this function of this workshop. Here, we have been listening to eminent speakers deliberating their expertise in practical sessions since morning. All these valuable insights gave us a new perspective that one should adopt while discussing these issues. May I now request Dr. C.R. Bobde, sir, to introduce valedictory function. Over to C.R. Bobde, sir.
Hello. Good evening, all of you. Today, we arranged this one-day workshop on experimental physics. The aim of doing this arrangement was to get acquainted. BSc students means BSc students should know what they have to do in future when they get admission to MSc, etc. And secondly, we have started our MSc physics program this year. So we had certain difficulties. Our students had certain difficulties. So we wanted to know what are the practical difficulties and how they can be solved from ideas of using ideas of experts. So today, I think we have achieved both the aims. That is, some BSc students participated from different colleges and our college too. I think 4 colleges are there from Sangli district in this area, which are under Leeds College scheme. So all the colleges, all 4 colleges having science wing, they have participated. Similarly, our BSc and MSc students have also actively participated in this workshop. And we had 3 experts. We purposely requested these 3 experts because they were related to basically practical physics syllabus of MSc course. And therefore, we got 3 experts, very intelligent experts, the experts who have really worked hard during their student life as well as a teacher. And we got expert views from those experts, and we have clarified most of our difficulties. So we have, in short, I can say that we have achieved whatever we wanted to do from this particular workshop. Today, in first session, we were given information about software, that is Mathematica, how to use Mathematica software by Dr. M.V. Takade sir from Department of Physics, Shivaji University, Kolhapur, in which he just displayed how to plot graphs, 2-dimensional, 3-dimensional graphs, how to plot multiple plots, how to use polar plots, then use of contours, etc. So these actually Mathematica software is very much useful to solve certain problems related to quantum mechanics. So you can use the quantum mechanical data and you can plot the plot the graphs using Mathematica software, and we can get clear-cut idea about the concepts of quantum mechanics. Similarly, in the next session, Dr. Nilesh Tarwasar, he actually gave information about the practicals related with MSc regarding solar cell, then LVDT, temperature transducer, staircase, ramp generator, Young's modulus of steel, series parallel LCR circuit. And he told the basic concept behind performing each of these experiments and what should be the result, how should we perform these experiments. So he gave us insight about each one of these experiments which he talked about in his talk. So it was again a very much knowledgeable, very much intellectual, and very much informative talk to our students, and our students will definitely be benefited from his talk. The last was again the talk by one of our family member, young expert, young scientist, Dr. Namdev Harare, with whom I am acquainted with for last 10 years. I know how much he has done his research, what is the depth of his research, what is his research contribution. And having known about his intellect regarding research ideas, etc., we purposely invited him. We are seeking his advice for last 4 or 5 months regarding practical setup at our college, MSc practical setup at our college. So I was really highly, it was very appreciating in the sense he told us about how to perform XRD diffraction experiments, with how to analyze the XRD data, how to analyze crystal structure using neutron diffraction technique, then Planck's constant, Stephen's constant, etc. So all these experiments, he gave deep information and how to perform these experiments practically. So we'll use these ideas to set up our MSc practical course. This will be helpful to MSc students, and it will be also helpful to BSc students who are doing their BSc in physics, who are last year students of physics, and they will know what is there at higher level. So this workshop was very much useful for us, and I am really satisfied with whatever thing we have done since morning today. So that is what I wanted to say about this thing. Thank you very much.
Thank you very much, sir. Is anyone from audience interested to give feedback about the workshop? Priyanka Gharge raised hand. Please unmute.
Okay, ma'am. Hello.
Hello.
Respected teacher, principal, all about staffs. There are all related workshop in a college. They are most inspiring to all of you. You are highly thankful for these efforts taken by this workshop. First section very inspired to me. There are use of a software like a Mathematica. They are using software. They are useful for me. There are do not use of pencil and pen. They inspire to me. And next section is the Tarai sir. There are useful information about the experimental knowledge. They include that in these sections. They are useful for me. Very thankful for us. And last one is a Harai sir. There are very useful knowledge introduced that in experimental. The so many experiment include that solar cell, Planck constant, Stephen constants. So many include that information knowledge. And you are highly thankful to you for efforts taken by the touching there are me and a student in online workshops. You are doing wonderful. Thank sharpening knowledge and the using new technology. Thank you so much.
Thank you, Priyanka.
Kindly welcome our guest.
Okay, for this valedictory function, we have Dr. J.S. Godke sir, Head Department of Physics, PDVP College, Tasgaon, as a president. Please, may I request Dr. J.S. Godke sir to give presidential remark.
So, मॅडम सरांचं इंट्रोडक्शन
हॅलो, आवाज येतोय ना सर?
एक मिनिट सरांचं इंट्रोडक्शन मॅडम.
Has may I request Dr. C.R. Bobde sir to give the introduction of Dr. J.S. Godke sir.
Dr. J.S. Godke sir is working as head of the department at PDVP College, Tasgaon. He is associate professor and he has teaching experience of about 25 years. He is a research guide and 2 students are working under his able guidance. And I am very much grateful to you, Godke sir, for accepting our invitation to preside this function at the last minute. So I am really grateful to you, sir. I welcome you to the valedictory function and I request you to pass your presidential remark regarding our workshop.
Okay, sir. Okay, sir. Good afternoon, one and all. Sir, आवाज येतोय ना? Am I audible?
Yes.
Okay. Thank you for a kind introduction and thank you for inviting me to share presidential remark of today's workshop. Respected Honorable Principal Dr. R.S. More sir, Balwant College Beta, HOD Department of Physics, Balwant College Beta, Professor C.R. Bobde sir, Coordinator one-day workshop on experimental physics, Dr. Vanita Raut ma'am, resource person, organizing committee members, participants, and my students under lead college cluster. It gives my great pleasure to share thought with you on the occasion of a valedictory event of the one-day workshop on experimental physics organized by Balwant College Beta under lead college scheme, Shivaji University, Kolhapur. The main aim of arranging this workshop is that how to learn, study, experiment in physics and promote students to use of experimental methods to analysis of problems. In this workshop, innovative experiment in physics for classroom teaching will be easily discussed by a resource person. Their suggestion and ideas will help the student in future for physics related experimental work. Hence, due to this workshop, student interest for performing the experiment in physics will be increases. Today's resource person, Honorable Dr. M.V. Takai sir, discuss some innovative graphical plot methods to make physics understandable and enjoyable at BSc as well as MSc level with demonstration experiments. He has demonstrated various softwares which are useful in understanding the physical concept. Some of them are Mathematica, C, Python, BioPython, etc. Especially, they are discussed techniques about how to employ Mathematica software to physics, which is helps to study physics experiment. They give us information about
which facility commands available in this software. They have also discussed different plots such as parametric plot, counter plot, density plot to solve different problems related to different branches such as quantum mechanics, differential integral calculus, ordinary differential equations, as well as mainly one branch that is optics related problems. विद्यार्थ्यांना माहित असेल ऑप्टिक्स रिलेटेड जे प्रॉब्लेम असतील, ऑप्टिक्स रिलेटेड जे एक्सपेरिमेंट आहे आपण म्हणू किंवा क्वांटम रिलेटेड जे प्रॉब्लेम असतील, बाय युझिंग दिस सॉफ्टवेअर, म्हणजे सरांनी जे सॉफ्टवेअर जे सांगितलं असेल, मॅथमॅटिका सारखं सॉफ्टवेअर मला वाटतं सर MSc ला यूज करत असतील. ओके, पण BSc लेवलला आपण साधारणतः C लँग्वेजचे प्रोग्राम्स वगैरे आपण आता आहेत आपल्या सिलेबसमध्ये BSc थर्ड इयर जे होईल. परंतु मॅथमॅटिकल सारखं जर सॉफ्टवेअर जर आपण जर इंट्रोड्यूस केलं असेल किंवा जर त्याची जर आपल्याला माहिती असेल तर निश्चितच BSc लेवलचे जे एक्सपेरिमेंट असतील, साधारणतः सरांनी सांगितल्याप्रमाणे ऑप्टिक्स चे जे एक्सपेरिमेंट असतील, ग्रेटिंग असेल किंवा सिंगल स्लिट डिफ्रॅक्शन पॅटर्न जो असेल तो विद्यार्थ्यांना इझिली ते एक्सपेरिमेंट समजतील. अतिशय चांगले अशा सरांनी आपल्याला या मॅथमॅटिक्सच्या सॉफ्टवेअर रिलेटेड आपल्याला त्या ठिकाणी सरांनी इन्फॉर्मेशन दिली असेल. डेफिनेटली ऑल दिस इन्फॉर्मेशन युजफुल फॉर फिजिक्स, इलेक्ट्रॉनिक्स, ऑप्टिक रिलेटेड एक्सपेरिमेंट as well as research purpose. Also, resource person Dr. Tarwal sir, Dr. Harai sir has discussed some basic concept of physics, nanotechnology, electronic circuits, and explain some experiments in a detail. Stephen's constant, Hall effect, solar cell temperature transducers, etc. That is, all these sessions was quite informative, and student benefited immensely from their interactions. From this virtual workshop, really student, teacher understand how to perform some physics, electronics, optics related experiment, as well as get knowledge about Mathematica softwares in detail. Thus, this workshop has highly informative and gave an overview of physics experiments. I thank the organizer once again for inviting me for a valedictory session and for giving me opportunity to interact as a presidency remarks with you all. Thank you all of you. Over to ma'am.
Thank you, sir.
Thank you.
Now, I would like to request Dr. V.S. Raut ma'am to propose the vote of thanks.
Good afternoon, one and all. Since morning, we virtually gathered over here for one-day workshop on experimental physics organized by Department of Physics, Balwant College, Bhita. Principal of our college, respected Honorable Dr. R.S. More sir, President of today's function, Honorable Dr. J.S. Ghurke sir, Head Department of Physics, PDVP College, Tasgaon. Resource persons Dr. M.V. Takre sir, Dr. Nilesh Tarwal sir, Dr. N.S. Harare sir, Head of Physics Department, Professor Dr. C.R. Bobde sir, worthy teacher participants, my departmental colleagues, and most beloved students from various colleges. Last but not least, all virtually gathered over here for this valedictory function. Now I am here to propose vote of thanks of this workshop. So initially, on behalf of Balwant College Bhita, I mention my deepest sense of gratitude to President of valedictory function, Dr. Ghurke sir, for presiding this valedictory function and sparing time for us. Sir, you have encouragement for us. We have been very happy to be assisted by you. Thank you, sir. Thank you very much. I would like to thank our principal, Dr. R.S. More sir, for his enthusiastic support and financial support. Thank you, sir. I am thankful to authorities of the lead college for providing the financial support. I, on behalf of Balwan College Beta, extend a very hearty vote of thanks to Chief Guest Dr. M.V. Takre sir, Department of Physics, Shivaji University, Kolhapur, who spared time from his busy schedule to grace this lead college workshop. Sir, definitely your words have stimulated us. You thoroughly discussed silent features of the software Mathematica. Thank you, sir. On behalf of Balwan College Beta, I am thankful to Speaker of Session First, Honorable Dr. Nilesh Tarwal sir, for gracing us with your crucial efforts and sharing with us the details of various experiments. Thank you, Tarwal sir. Thank you very much. I would like to thank resource person of session second, Dr. N.S. Rai sir, for their guidance regarding practicals. Thank you, sir. You also thrown light on emerging research areas. Definitely, it will be useful for students. Thank you, Harar sir. Thank you very much. I would like to thank Head Department of Physics, Professor Dr. C.R. Bobde sir, for constant encouragement, help, and support. Sir nicely introduced chief guest and president of inaugural function. Thank you, sir. I am thankful to Miss S.M. Rautale ma'am for nice introduction of resource person, Dr. Harare sir, and for rendering help as per the requirement. I am thankful to Mr. D.K. Dhongde sir for brief introduction of resource person, Dr. Tarwal sir. I specifically thank our technical arrangement team, which is Mr. D.K. Dhongde sir. Thank you, sir. Thank you very much. Further, a very big thank you to master of this workshop, anchor Ms. Priyanka Shinde, for their efforts anchoring of today. Again, I am thankful to Priyanka Gharge for his encouraging feedback. I am very thankful to all dear students who have been backbone of this virtual event. I would place on record my hearty thanks to all the participants, because of whom we made this workshop possible. I also extend thanks to all departmental colleagues for their cooperation in the institution for this workshop. Thanks to all the people who were directly and indirectly helped to make this lead college activity successful. Thank you. Thank you very much. So this is a fruitful workshop. With the permission of President, I declare the program is over. Thank you. Thank you very much. Thanks to all.
Hello. Feedback link is shared in the chat box. Huh?
Thank you, Harare sir. Nicely explained you.
Thank you, ma'am. Thank you, sir. Thank you all.
All participants are requested to fill the feedback form.